Welcome back. In today's video, we are going to talk about summation, and we are going to work with the function called sum and sum. So here is my array. This is called x, and it has these elements 1, 3, 5, 7, 9, 11, 20, and 50. So these are the elements of my array. First of all, I print my array in the output to have it here for the reference. So I print the array called x. Then I would like to compute the total sum of all elements in the array, meaning that I would like to compute this number. So 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 20 and plus 50. What is the output? I would like to know the output. In order to know the output, we use the sum function, and in parentheses, because we want to know the sum of all the elements in the array x, we write down the name of the x, and we assign the output to this variable sum underscore x, and we print the sum underscore x in the output. So the sum of all elements in this array is 106. So this is the first thing. Now, how can we compute the cumulative sum? So it means that running total. Let me illustrate it with the example. So the first element is number 1, the second element is number 3. So to compute the cumulative sum or running total, it means that we are going to have the first element as the first element, but the second element is the addition of first element plus the second element. So 1 plus 3, it's 4. Then we are having 9 here. It means that 4 plus 5, it became 9. Okay. So now in order to calculate the next one, we are having 9 plus 7, it is 16. 16 plus 9, it is 25. 25 plus 11, it is 36. 36 plus 20, it is 56. And plus 50, it's 106. So this is the running total. So it means that the first element is being added to the following element. 1 is the first element, we write it down. Then 1 plus 3, it's the running total is 4 so far. 4 plus 5, we are having 9. 9 plus 7, it is 16, etc. until the end. This is what we call cumulative sum or running total. But how can we compute that? In order to compute that, we use the sum function. So sum of all the elements in the array called x, it is assigned to this variable, and we are printing it here, and we see it in the output step by step how we proceed to reach the total sum that we are having in the output 106 here, and we calculated earlier. Now let me illustrate a two-dimensional array. This is called y. It has 2 rows. This is the first row, this is the second row, and in each row we are having 3 columns. 1, 2, 3, the first row, 4, 5, 6, the second row. And we are printing the array y for the reference here. So we see that there are 2 columns, there are 2 rows, and there are 3 columns here. You see? Okay. Now we would like to sum over all the elements in the array called y, meaning that I would like to know the output of 1 plus 2 plus 3 plus 4 plus 5 plus 6. What is the output? Again, in order to calculate that, we need to use the sum function. We use the sum function to calculate the sum of all the elements of the array called y, and we assign it to sum underscore y, and we are printing it here in the output. So when I print it in the output, we see that the sum of all the elements is 21. So we see that 1 plus 2 is 3. 3 plus 3, it's 6. 6 plus 4, it's 10. 10 plus 5 is 15, and plus 6, it's 21. We see that the sum of all the elements in the two-dimensional matrix or array is 21. Okay, so this is how we can do that. But how can we sum along the axis 0? So column wise means the following. So here we see that we are having the 5, 7, and 9. We are doing the column-wise summation, meaning that this is the original array. We are having the 1 plus 4, it's 5. We are having 2 plus 5, it's 7. We are having 3 plus 6, it's 9. So this is what we call column-wise summation. In order to do the column-wise summation, we simply call the sum function, but we need to have in parentheses two parts, one before the comma and one after the comma. The one that is before the comma is again the array that we would like to perform the summation over, so it is the array y. But when we are having the after the comma, we need to mention that put the access to be equal to 0. So this way the compiler understands that we would like to have the column-wise summation, and the output is being assigned to this variable, and it is being printed here that we see here. Okay. Then we would like to have the row-wise sum, meaning that we are having this original array, 1 plus 2 plus 3, the output is 6. So we see that the 6 is there. 4 plus 5 is 9, 9 plus 6 is 15, and 15 is also there. So this is the row-wise summation. We are adding all the numbers that are in one row. In order to do that, we again call the sum function. We write down the name of the array, which is y, but this time, because we would like to do the row-wise summation, we assign access to be equal to 1. So when we would like to do the column-wise summation, we assign access to be 0. When we would like to do row-wise summation, we assign access to be equal to 1. Now we would like to have cumulative sum along rows. What do we mean? What do we mean by that? Means the following. So this is the original array that we are having here, 1, 2, 3, 4, 5, 6. And this is the cumulative sum that is row-wise, meaning that 1 is the first element. We write it down here. So 1 plus the next element, which is 2, is 3. So the 3 is written here. So 3 plus the next element, which is again 3, it's 6. Here we see it. Then we are having the first element that is 4. So we write down 4. 4 plus 5, it's 9. 9 plus 6, it's 15. So this is what we call cumulative sum row-wise. In order to do that, we use the com_sum function. We write down the name of our array and we put the access equals to 1, so it understands that we are going to do the cumulative sum row-wise. And if we would like to do the cumulative sum column-wise, we use the same function, but this time we are going to assign access to be equal to 0. When it is equal to 0, we see that the first row is written as the original array. And because it is a column-wise cumulative sum, we see that this row is being added to this row. So the first row is, the first element is 1. 1 added by 4, it's 5. So the output is written here. So the other element is 2. 2 plus 5, it's 7. We write it down here. And then we are having 3 plus 6 being printed here, 9 in the output. So this is the column-wise summation. So in this video, we performed some action over the summation using the sum and com_sum functions. We are having the first of all an array that is one-dimensional. We calculate the sum of all the elements in the array and we calculate the cumulative sum of the array again. We declared a two-dimensional array. We calculate the sum of all the elements and then the column-wise sum, row-wise sum, and we have the cumulative sum along rows and along columns. Thank you for watching. Hello and welcome to this video. In today's video, we're going to learn how to create a one-dimensional array in NumPy using NumPy library. So first of all, we are importing the NumPy library, and in order to create a one-dimensional array using the NumPy in Python, we need to have the NumPy.array. Okay, so this is the code we need to create array using NumPy. And here we see that I am creating an array, and these are the elements of the array: 1, 2, 3, 4, 5. So there are 5 elements in this array, and the name of the array is array1. After creating and initializing this one-dimensional array, we are simply printing this array. So we use the print function to print this array, array1. Okay, and when we run the code, we see that actually this array is being printed in the output. So here we are creating an array called array1, and to create it, we use the NumPy library, so np.array, and these are the elements of the array that we are having here. Okay, it's like a simple list. In order to print the elements that are inside my array1, I use the print function, and inside parentheses, I write down the name of my array. This is why we see 1 to 5 here in the output, representing the numbers of my array. Also, in order to understand the type of the array, because there are different types of arrays that we can have, in order to understand the type of the array, we simply write down, first of all, the type. Inside parentheses, I write down the name of my array. So the name of my array is array1, is inside the parentheses of the type function in order to understand its type. And in order to print its type, I use the print function here. Okay, so I use the print function, then to print the type of the array1. And we see that the type is from the NumPy array. Basically, this is how we can have a NumPy array. So I can have array2 equals np.array, and then we can have here, for example, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is another array that I am creating here. It is called array2. It's a NumPy array, and the elements are from 2 to 10. And now if I want to print it, I simply use the print function and write down the name of my array, which is array2. So when I run the code now, I see that these elements are being shown in the output from 2 to 10. Also, we can have the type of this array2 to be printed in the output. So when I run, we see that it's a NumPy array. Basically, this is how we can create and display a one-dimensional array in Python using NumPy. Thank you. Welcome back. In today's video, we're going to learn how to create a two-dimensional array in NumPy. So two-dimensional arrays. Okay. So in order to create a NumPy array, we learned that first of all, we need to import the NumPy library as np. So we use the np.array to create our array. And we are having the square brackets here, one square bracket and another square brackets. So, and all of them are in another square brackets. Okay. So this is the array. This is the two-dimensional array that we would like to display. So it has 2 rows and 3 columns here. Okay, 1, 2, 3, the first row, 4, 5, 6, the second row, 1 and 4, the first column, 2 and 5, the second column, and 3 and 6, the third column. Okay, now in order to, so this is a two-dimensional array, or we can call it a matrix if you want. In order to create that using NumPy, we can have the, first of all, we should have the name np array. Okay, then inside parentheses, first of all, we are having the square brackets that we need to have. Then for the first row, we're going to have another square bracket, comma, another square bracket. So this is this one. This first square bracket represents the first row. This one represents the second row. And this one, these two, this one, and this one represents the whole array. So in the first row, we would like to have 1, 2, and 3. In the second row, we would like to have 4, 5, and 6. So here is how we can have 2 rows and 3 columns here. We are having 1, 2, 3 in square brackets representing the first row. We are having another square bracket 4, 5, 6 representing the second row. And all of this that is created is assigned to this name, which is array2. And when we are printing array2, we see that 1, 2, 3 is the first row, 4, 5, 6 is the second row. And if we want to have, for example, a third row, we could have like 7, 8, and 9. So as you see, I created the third row using another square bracket, which was separated by a comma from the second row, which itself was separated by a comma from the first row. But after the third row, we have nothing, no more comma. So if I run the code now, we see that we are having 3 rows now with 3 columns. If I want to have 4 columns for each row, I need to add a number. For example, number 2. Here again, number 2. And here again, number 2. So when I run the code, we see that we are having 1 row, 2 row, and 3 rows. We see 1 row, 2 row, and 3 rows. And we see that we are having 4 columns now. You see, because in each row we are having 4 numbers. Each row we are having 4 numbers, and in each row we are having 4 numbers. Therefore, we see that we are creating a 2-dimensional array that has 3 rows and 4 columns, and we can adjust it as we want. The point is, for each row, we need to have the square brackets, separated the square brackets, and the number of numbers that are inside one square bracket is going to represent the number of columns. So we are having 4 numbers, 4 numbers, 4 numbers, meaning that we are having 4 columns. But we are having 3 square brackets, this one, and this one. Therefore, we are having 3 rows. This is how we can create a 2-dimensional array in Python using NumPy. Thank you for watching. Welcome back. In today's video, we are going to discuss 3-dimensional arrays. Here, we are importing NumPy as NP, and we use np.array to create our array here, and we name it array3, and we are printing our array here. So when I print the array, we see that we are having layer 1 here and layer 2 here. So there are 2 layers, this part and this part. In order to make sure that we are creating a correct 3-dimensional array, we need to be very careful about the square brackets here. So for creating an array, we write down np array with parentheses, and inside parentheses, first of all, we are having the first square brackets that we are having here. Okay, so first of all, we are having the first square brackets within which we are going to declare the array. So this is the first square bracket that you see here. This is the last square bracket that we are having it here. So now, in order to have the first layer, we are going to have another square bracket inside which we are declaring the first layer rows and columns. So in the first layer that we are going to present here, we are having 2 rows. Okay, so 2 rows, it means that we are going to have another set of square brackets, two sets of square brackets. So this is for this one, and this one is for the first layer, And inside the first layer, because we are having two rows, this is the first row. Sorry, this is the first row and this is the second row. Okay, so I review it one more time. We are having the square bracket here and here for the start and the ending points. Then we are having two layers, as you see. In order to illustrate the first layer, I'm having this part. Okay, this one and this one, the first for the first layer, and this one for the second layer. But in the first layer, we see that this is the first layer. In the first layer, we see that we are having two rows. Therefore, we need another two sets of square brackets. This one and this one. So here I'm going to write 1 and 2. Here I'm going to write 3 and 4. Therefore, I created the first layer. This is the start of the first layer. This is the end of the first layer. This is the first row of the first layer. This is the second row of the first layer. And we see that first layer has two columns. Why? Because we are having only two numbers in each square bracket. Now let us illustrate the second layer. So the second layer is this one. Because we are having again two rows in the second layer, we are going to have 1 and 2 sets of square brackets. And here we're going to write down 5 and 6, and here we're going to write down 7 and 8. Therefore, here we learned how to create a three-dimensional arrays which has two layers, the first layer and the second layer here. But what if I want to have, instead of having two columns that you see here, instead of that, if I want to have three columns? Simply, here is my first row, okay? I can have another number there. I can have another number there, another number there, and another number there. So when I run this code, we see that we are having a three-dimensional array that has two layers. This is the first layer, this is the second layer. In each layer it has two rows. We see first row, two row for the first layer. For the second layer, first row and the second row. And each row has three numbers, meaning that three columns are there. 1 2 2 3 4 2 5 6 2 7 8 and 2 and 2. And if we want to have three rows in each layer, so we are having two rows now in each layer. If we want to have two rows in each layer, we should have something like this. So another set of square brackets, we're going to have 1 1 1, and here we can have 2 2 2. So when I run this code, we see that now in the first layer we are having three rows. In the second layer also we are having three rows. So this is how we can declare a three-dimensional array using NumPy, and we name it array3, and finally we print array3 so we see it in the output here. Thank you for watching. Welcome back. In today's video we're going to talk about the type of arrays that we can create. So here is another example. We are importing the NumPy as np, and we would like to create an array. So np.array, and then we are having three elements in our array, 1, 2, and 3.5. Then separated by a comma, we can have the keyword dtype equals float, telling the compiler we would like to have a float array here using the NumPy, and we name it array4. And then we are printing array4, and we see that here we are having the exact same numbers, 1, 2, and 3.5. And if we want to print the dtype, let's say the type of the array, we simply use the print function. We write down the name of our array dot the keyword dtype, and it is going to give us the float in the output, meaning that it's a float type of, this is an array of the float type, let's say. But if I put it to be integer here, int, if I put it here, you see that we are having 1, 2, and 3.5. However, in the output, we are seeing 1, 2, and 3. So everything is seen as an integer. And also, the type that is being printed in the output is an integer. So here we learned how we can have an array that we can decide its type as well. So here I would like to have another array. My array equals np dot array, and we open the parentheses. Inside square brackets, I'm going to have the numbers. Then I put a comma. Then I would say d type equals float, for example. And finally, I'm going to print my array. We see it here. So this is my array. 1, 2, 3, 4, 5. And if I have, for example, 2.3 here, 4.6, 5.9, for example. So these are the numbers that I have in my array, and I would like it to be of type float, and we see it in the output here. 1, 2.3, 3, 4.6, 5.9. And when I print the type, we see that it's of float type. But if I change it to be integer, int, when I run, we see that every number that we had there is rounded down. So 1, 2, 3, 4, 5, exactly that what we have here, but they are rounded down to the closest integer. So 1, 2, 3, 4, 5, and it's of integer type. So in this video, we learned how we can have the type of the array being declared while we are creating our array using NumPy. Thank you for watching. Welcome back. In today's video, we are going to learn how we can convert a Python list to a NumPy array, and also we are going to learn how to convert a tuple to a NumPy array. So first of all, we are going to import NumPy as np, and this is a list that we are creating here. So this is a Python list. So the Python list is this one. So we are having 1, 2, 3, 4, 5. This is my list in Python. And in order to convert it to a NumPy array, I'm going to write down np.array. This is the keyword that we've been using. Inside parentheses, I'm going to write down the name of my Python list. And it is assigned to a variable called array. And we are printing this array. So when I print this array, we see the exact same numbers in the output as we had here. But the difference is that this one is the NumPy array, but this one is the Python list. So if I print also the py list, and here I write this message as well. So this is the NumPy array. This is the Python list. So when I run this code, we see that this is the NumPy array, and this is the Python list that we are having here. So the first one is the NumPy array that we converted it. This is the array being printed. The second one is the original Python list that we had it here. So in order to convert a list to a NumPy array, we simply write down np.array, and inside parentheses, we are going to write down the name of the list we want to be converted. For example, now if I have another list, I simply write down np.array, and inside to parentheses, I should write down the name of my Python list. Okay. And this should be assigned to a new variable. A new variable. So this was how we could convert a Python list to a NumPy array. Now we would like to convert a tuple to a NumPy array. So here is my tuple. Here is my tuple. We are having it inside parentheses. You see it here. And these are the elements 10, 20, 30, and 40. And the name of the tuple is py underscore tuple, meaning that Python tuple. Now, again, with the same methodology, we can change and convert this tuple to a NumPy array. So in order to do that, I write down np.array, and inside parentheses, I write down py_tuple. When I write down py_tuple and use the np array, compiler is going to convert this tuple to a NumPy array and assign it to array2, and we are simply printing array2 here in the output. So we see that this is the NumPy array. Let me add this message here. This is the NumPy array. Also, if I want to print the tuple, we could have, this is the Python tuple, and here we are going to have py tuple. So when I run, we see that this is the NumPy array that is being here printed from this tuple. So this is the tuple. This is the Python tuple 10, 20, 30, and 40. And this is the NumPy array 10, 20, 30, and 40. So in this video, we learned how we can convert a Python list and a Python tuple to NumPy arrays. Thank you for watching. Welcome to this video. In today's video, we would like to talk about array properties. So we're going to learn about these properties of arrays. First of all, we are going to learn about ndim. It means that we are going to know the number of dimensions or axes in our array. We're going to learn about the shape, so tuple representation of the shape of our array. We learn about the size of our array, so total number of elements that are in the array. We learn about the data type of the array elements, and finally, we learn about size in bytes of each element in the array. So here we illustrated these properties through examples. First of all, we are importing the NumPy library as np, and we are creating a NumPy array. In order to create a NumPy array, we simply use the np.array, and then we are having our array declaration here. So we are having a two-dimensional array here, and we are having 2 rows and 3 columns. When I print the array, you see that we are having 2 rows and 3 columns. How do I know that? We are having 2 rows by just looking at this code, because we are having 2 square brackets, each representing one row, and in each square brackets we see 3 numbers representing 3 columns. So this is why I understand by looking at the code that we are having 2 rows and 3 columns. Also, we decide the type of the NumPy array to be of a float type. Now we created our array and we name it to be ARR, or let's say array. In order to display array properties, first of all, we are having the print of the original array. So we see that we are having the print of the original array here. This is the print of the original array. So let me comment the other parts so it would be clear to go through the properties one by one. So you see now we are having the print of the array. We are having the first row, 1, 2, 3. We are having the second row, 4, 5, 6. And we are having 3 columns here. Okay, so this is the original array that we are printing. But if we want to know about the number of dimensions in our array, we learned that we need to use ndim. So we write down the name of our array, which is ARR, dot ndim is going to help us to know about the dimension of our array. And it says the number of dimension in this array is 2. So this array is a 2-dimensional array. Using ndim, we can understand it. Then we would like to have the shape of the array. So the shape of the array is the tuple representation of the shape of the array. So when I run the code, we see that we are having a tuple with number 2 and 3. But what does it mean? It means that we are having 2 rows, and 3 columns. 3 columns. So this is how we know about the shape of the array. So 2 rows and 3 columns. So if I add one number here and one number here, it means that now we are having still 2 rows because we are having 2 square brackets here, but we are having 4 columns because in each square bracket we are having 4 numbers. It means that we are having 4 columns. So when I run the code now, we see that the rows, the number of rows, it is still 2, but the number of columns, it is 4 now. So you see that this is the number of rows and this is the number of columns, and we can get it by using the name of the array dot shape. And this is going to help us to understand about the tuple representation of our NumPy array. Then we are having the total number of elements, or let's say the size of the array. So here it says 8, meaning that we are having 8 elements in our array. So it's 1, 2, 3, 2, 4, 5, 6, and 2. So we are having 8 elements, and this is going to help us to find it using the size. So we write down the name of the array dot size. This is the size of the array. So this is another thing. The next thing that we would like to check is the data type of the elements. So we have the d type equals float, and in the output we see that it's float. So if I put it to be integer, we see that it will be integer in the output. In order to find that, we write down the name of the array dot d type. And after that, we are also having the size of each item in bytes. So when I run the code, we see that each item in my NumPy array is having 8 bytes in the memory. It's consuming 8 bytes in the memory. So array, the name of the array, which is arr.item size, is going to help us this number, which is the size of each item in bytes. So in this video, we learned about array properties. In particular, first of all, we learned how to know the number of dimensions of an array using the name of the array .ndim. Then we learned about the tuple representation of the shape of the array. For example, in this case, we were having a tuple of 2 and 4. So it was something like this, 2 and 4. 2 was representing the number of rows, and this is the number of rows. This is the first row. This is the second row. And 4 was representing the number of columns here. So 4 columns, it was representing that. Then we learned about the size of the NumPy array, so the total number of elements that are there in our array. We are going to have it using the name of the array dot size, and in order to understand the size in bytes of each element in the array, we are going to write down the name of the array, then dot d type. This is going to also give us the size of each item in bytes. Thank you for watching. Welcome back. In today's video, we are going to learn how to create arrays using different NumPy functions. First of all, we would like to create an array filled with zeros. In order to do that, we use the np.zeros, and within parentheses, we're going to write down 3 and 3, meaning that we're going to have a 3 row with 3 columns array, and all of the elements are 0. So when I run the code, we see that we are having an array of 3 rows and 3 columns, and we see that all of the elements are 0. 3 rows, 3 columns. Okay. How do we know that we are having 3 rows and 3 columns here? Because we choose 3 rows and 3 columns here. If I want, I can have, for example, 3 by 5. When I run, we see that I have 3 rows and I have 5 columns. Okay. In order to have an array filled with zeros, we simply use the zeros function, and in parentheses we choose the rows and columns, and the name of my array is the zero array. And when I'm having the zero array here, we see that when I want to print, I write down this message, array of zeros, and here we are having the name of my array. So when I run the code, we see that we are having array of zeros in the output. So let me comment this part. Then we can have an array filled with ones. You see, here I'm having an array that is having 3 rows and 3 columns, and all of the elements are 1. So again, here is the number of rows, here is the number of columns. So we can have 3 by 5, for example. When I run, you see we are having 3 rows and 5 columns now. But one important thing is that we are using the ones function. So the ones function is going to help us to create an array with 3 rows and 5 columns that all the elements are number 1. And we assign it to this name. So the name of my array filled with number ones that has 3 rows and 5 columns is ones array. Then we are going to print this message, array of ones, and we write down the name of the array, so we see that it's in the output here. Then the next thing that we can have is we can have an array of 3 by 3 filled with number 7. So when I run, we see that we are having an array that is 3 by 3, and this array is filled with number 7. So if I want, I can have 3 by 5, for example, and all of them are filled by 7. We can have all of them filled by 5, for example, or all of them are filled by 14, for example. So if we want to create an array filled with a specific value, we can simply write down the name of that value, and these are the dimensions of our array. Simply we need to use the full function. And if I comment this part and go to the next one, we see that we can create an identity matrix that has here all zeros except for the diagonal. Okay, for the diagonal we're having number 1, so this is the identity matrix. The other elements are 0. In order to create that, we write down the function called I, and we put number 3 to have, for example, a 3 by 3 matrix. If I want a 5 by 5 matrix, we simply write down number 5. So we are going to have the 5 rows and 5 columns, and the diagonal is filled with number 1, so we are going to call it identity matrix, and we are printing it here in the output. Finally, we learn about how to create a matrix that has a diagonal with specific elements. So here I use the dig function, and we decide about the specific values that we want to be shown in the diagonal. So 1, 2, 3 are the numbers that I am expecting to see in the diagonal. So if I add one number here, for example, number 4, we're going to have a 4 by 4 matrix. So if I have 5 numbers here, I'm going to have a 5 by 5 matrix here. Okay, so in this video we learned how to create an array filled with number zeros. All of the elements are zeros. We learned how to create an array that all the elements are number 1. We learned how to fill an array that all the elements are a specific number, for example, number 7, or any other number that we choose. We learned how to create an identity matrix, and also we learned about the specific elements that we can have for our diagonal matrix here. So we see that we are having a 5 by 5 matrix, and the diagonal is having the specified elements that we chose here. Thank you for watching. Welcome back. In today's video, we are going to learn how to create an array using different functions. First of all, we are going to import the NumPy library as NP. In the first function, we learn about how to create an array with a range of values with a specific step. So we are going to use the arrange function to do that. We write down the arrange function. So number 1 is the starting point, number 10 is the ending point, exclusive, and 2 is the step by which we are going to proceed in creating this array. And this array name is arrange array. So when I print this arrange array, we see that we are having number 1, so the starting point, and we see that we are going forward exclusively to 10. Okay, so 10 is not included. So we're going to from 1 to 9, and in each step that we are going to reach the ending point, we are having the step of 2. So this is why the first number is 1, this is the starting point, then the plus number 2, which is our step, it will be 3, then it will be 5, then it will be 7, and then it will be 9. So we are going to start from 0 and end at 9 because 10 is exclusive, and the step, the incremental step is 2. If I write down the incremental step to be 3, so we start from 1, we are having 1, then we add 3 numbers to that, it will be 4, 3 numbers to that, it will be 7, and if we add another 3 numbers, we will see that it will pass the number 9, so it is not going to print that. So for example, this is the first number, plus 3 it will be 4, plus 3 it will be 7, plus 3 it will be 10. 10 is not in our range because we start from 1 and we want to end at 9, so 10 is exclusive, so we're going to go from 1 to 9, and this number is not in our range. This is why we don't have number 10 here in the output. And if I change this, so now it means that I'm going from 1 to 99 because 100 is exclusive. So when I run, we see that with the step 3, we are having number 1, 4, 7, 10, 13, etc. until we reach 97. And if I have the step 2, we see that the first number is 1, then 3, 5, 7, 9, 11, etc. until we reach 99. So this is how we can generate and we can create an array with a range of values with a specified step. So this is the first function. The first function was called arrange. Now let's talk about the second function. The second function is linspace. Here we are going to create an array with evenly spaced values between a range. Here is the starting point. Let me comment this part. And also this part. So here is the starting point 1, and here is the ending point, and this is inclusive, it's not like the previous function, and we would like to have 5 elements in this range that are evenly spaced values. So we are going to print this array. So we see that 1, 2, 3, 4, and 5. So we are having 5 elements that are evenly spaced. So if you calculate the difference between this number and this number, you see that it is equal to calculation of 5.5 minus 3.5. So they are evenly spaced values, meaning that 3.25 minus 1, the output is 2.25. Okay. And if I do the calculation for the next two elements, 5.5 minus 3.25, again, the output is 2.25 because they are evenly spaced. If you do the same with the rest of the elements, it will be the same as well. So this is the starting point, this is the ending point, and this is showing that we would like to have 5 elements that are equally spaced. Now, if I play with it a bit, so if I want to have, for example, 6 elements, here we see that we are having 6 elements that are evenly spaced. If I want to have, for example, 10 elements and I increment the range from 1 to 100, we see that we are going to have the starting point as 11, ending point as 100, and they are evenly spaced, so there are 10 evenly spaced values in this range that we see here: 1, 12, 23, 34, etc., until we reach 100. And for that, we use the linspace function. So we use np.linspace. We define the starting point, ending point, and the number of equally spaced values, and we assign it to, for example, here the linspace array, and we print it in the next line. So this was the second function. And the third function is when we would like to create an array with logarithmically spaced values. So when I run the code, we see that we are using the log space function. We are using the here number 1, number 3, and we would like to have 5 values. So it means that 10 to the power of 1, 10 to the power of 3, and in this range I would like to have 5 values. So this is my first value, second, third, fourth, and fifth. So the starting point is 10 to the power of 1, so we see that it's 10. 10 to the power of 3 is the ending point, which is 1000, and in this range we would like to have 5 equally spaced values, and we see that we are going to have it here. So logarithmically spaced values. In order to have that, we use the log space function. So np.logspace. So the starting point is 10 to the power of 1. This is something to just be careful about. 10 to the power of 3 is the ending point. And then we are having the logarithmically spaced values. So 5 values we are looking for. We assign it to this array that is called log space array, and we are printing it in the output as we see it here in the output. So in this coding exercise, we learned about 3 functions. The first one was the arrange function. We learned that if we want to create an array of values within a specified range and step, we can have the starting point, the ending point, which is exclusive, and the step to the incremental step. Then we learned about the linspace function, where we create an array with evenly spaced values between a range. So we are having between 1 and 100. So 100 is inclusive, and we would like to have 10 equally spaced values in this range. So we use the linspace function. And finally, we learned that if we would like to create an array with logarithmically spaced values, we need to use the log space function, where we are having the starting point 10 to the power of 1, for example, 10 to the power of 3, and we would like to have 5 values in this range. Thank you for watching. Welcome back. In today's video, we're going to learn how to generate numbers in a given range using different functions in NumPy in Python. So first of all, we import the NumPy library as np, and the first function that we're going to learn is random.rand. In this function is going to help us to generate numbers from a uniform distribution from between 0 and 1. So random.rand is going to help us to generate numbers using uniform distribution between 0 and 1. And each value here is drawn from a uniform distribution over, including 0, excluding 1. For example, here I would like to have an array that is 3 by 3 using the random values between 0 and 1. So when I run the code, we see here we are having a 3 by 3 array. So it's a 2-dimensional array. So 3 rows and 3 columns. And we randomly generated these numbers following a uniform distribution that contains numbers between 0 and 1. You see that all the numbers here are between 0 and 1, and they are uniformly distributed, generated. So every time that I run the code, we see a new array is being displayed here. So this is the first function, random.rand. So this was the first function. Let me comment this part and go for the next one. So next one is going to help us to, it's the random.randn. It is going to, in the end with an n, exactly like the previous one, but it ends with an n. An addition of n is there. So it generates random numbers from a standard normal distribution with the mean of 0 and the variance of 1. So it generates random numbers from a standard distribution, standard normal distribution with the mean of 0 and variance of 1. So this could be very useful when we are dealing with modeling the real world data, for example, that are following a normal distribution. Now here we are creating a 3 by 3 array with a standard normal distribution value. So when I run the code, we see that the array is generated. So we are having 3 rows and we are having 3 columns, and the mean is 0 and the standard deviation is 1. So whenever I run the code, we see a new array is being displayed here. This can be useful when we are dealing with a real world data set that follows a normal distribution. So this was the second function that we wanted to learn how to use to generate numbers in NumPy for our arrays. The third function that we would like to learn about is the random.randint or randint function. It generates random integer. This is why we're having int. Random integers within a specified range. Okay, so this function requires to have a few parameters. For example, here we are having the starting point, which is inclusive, the ending point, which is exclusive, and the size of our array. So the size, we would like to have an array that is having 3 rows and 3 columns, and its numbers are generated between 1 and 99 because 100 is exclusive. So when I run the code, we see that we are having an array of 3 rows and 3 columns here, as you see, and we are having numbers being generated between 1 and 99. We could have, for example, an array of 3 by 5, for example, so 3 rows and 5 columns, and we are having all the numbers being generated between 1 and 100. We could have, for example, between 1 and 99. We could have between 1 and 9. You see, these are the numbers. So we are using the random.randint function to generate random integers between the starting point and the ending point. And we need 3 parameters basically: the starting point, which is inclusive, the ending point, which is exclusive, and the third parameter is the size of the array that we are looking for here. Then we are having the fourth function. So the fourth function is random.uniform, and this is going to help us to generate random floating point numbers in a specific range, in a specified range. This is very useful when we want to have, for example, random values in a given interval. So you see that I am generating a 3 by 3 array that follows random floating point numbers generation within the specified range. So all the numbers are between 10 and 20. You see it here. And here is the starting point, here is the ending point, and here is the array that we are having. For example, a 3 by 3 array. So we could have a 3, for example, a 5 by 3 array. So we are going to have 5 rows and 3 columns. All the numbers are between 10 and 20. And this is going to help us to generate random floating point numbers, as you see here. So this was the fourth function that we wanted to discuss. Then we are having the fifth function. So we are having a random choice function. So we are going to, it is basically selects random values from a given array or list. Here are the choices that we are having here. For example, we are having number 10, 20, 30, 40, and 50. We would like to randomly generate numbers from this list to create a 3 by 3 array. So when I run the code, we are having a 3 by 3 array. And so 3 rows and 3 columns. And all the elements in this array are coming from this list. So we are using this list to randomly generate values. Okay, this is a very useful function when picking random elements from a data set. So this is my data set, and randomly we are taking numbers from this data set to generate our 3 by 3 array here. So this is the random.choice function. Then we are having the random seed. So sets the seed for reproducibility. Here we are setting a specific seed value, and then we are generating the same, we are using the same seed to ensure that the same random numbers are generated in each time we are running the code. And we are generating random numbers to have a 3 by 3 array. So we see that we are having 3 rows and 3 columns. We are having all the numbers are between 0 and 1 that are generated here. And you see that every time that I run, I get the same numbers. Why? Because we are having the seed for reproducibility. If I comment, if I comment this part of the code, we see that every time that I run, we get a new array with new numbers. You see? So if we want to have the same numbers for our array, we need to have the seed there. So now we're going to have the same seed. And this number is arbitrary, so we can change it as we want. So for example, I put it as 50. And now I generate, and we see that the numbers are not changing. For example, the first element is 0.49. When I run, I get the 0.49 again and again. So in this video, we learned how to work with functions to generate random numbers for our arrays. First of all, we learned about the random.rand to generate numbers uniformly between 0 and 1. So here we are generating a 3 by 3 array, for example. Then we learned about random rand n to generate random numbers from a standard normal distribution with the mean of 0 and variance of 1. Then we learned about the random.randint, meaning that we would like to generate random integers within a specified range. We learned how to have random floating point numbers in a specified range using the random.uniform function. Then we learned how to select random values from a given array or list. It's very useful to pick some random elements from a data set, for example. And then here we learned about random.seed that helps us to set the seed for reproducibility and ensure that every time that we run the code, we're going to get the same random numbers. Thank you for watching. Welcome back. In today's video, we're going to learn about different operations that we can do with NumPy array. For example, we learn about the creation, about accessing a single element, accessing the last element, about slicing, about step slicing, accessing multiple elements, Boolean indexing, modifying elements, and negative slicing or reversing the array. So we're going to learn about all these 8 topics. First of all, this is my array. We learned how we can create it. We use np.array, and we are going to, inside the parentheses and square brackets, we're going to write down the elements of our array. and we assign the name of ARR to it. In order to access one specific element in this array, first of all, we need to learn about the indexing. So the first number in our array has the index 0. Then the next one has the index 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is basically how the indexing works here. So it starts from 0. So when we are looking for the element with index 0, it means that we are looking for number 10. The element with index 5, it's number 60, or vice versa. We can say, what is the index of element 90? The index is 8. So now that we learned about the indexing, we can access elements that are having different indices. So now I would like to access the element with index 3 of my array called ARR. So index 3, I write it in square brackets and then the name of my array. So here it's the index 3 of array. We see it here. So if I change the name of array, I could say, for example, array1. Then here I'm going to have array1. So this way I'm going to print the index 3, the element with index 3 from array1. So when I run the code, we see number 40. So index 3, we saw here, the index 3 is for number 40. Okay, so we see that if we want to access number 40, we need to write down the index 3. So we are having an array called array1. In order to access the element with index 3, we write down the name of the array, and in square brackets, we're going to write down the index, which is 3 here, and we're assigning it to a variable called single element, and we are printing that single element. And it is going to print us number 40. And if we, for example, look for another index, for example, if I look for another index, which is index 8, we know that index 8 is the element 90. So when I run the code, we see number 90 in the output here. So it depends what we are looking for. If we know the index, we can access that element from the array1 here, for example. Then we are having the last element to be accessed. So this is the name of array. So let me modify this again here. So another way of indexing is the following. So we can have indexing from left to right, starting from 0, but we can have from right to left as well. So we can call the last number to be -1, then -2, -3, -4, -5, -6, -7, -8, -9, finally -10. But we need to make it a bit closer to each other so they are going to be easier to be understand. So here is now the indexing. Let me modify the spaces. So you see here, now I'm having the indexing from right side. So indexing from left side is the following. We're going to start from 0 and we're going to continue until we reach the last element. Here we're having index 9. But indexing from right is different. So if we want to access a number that is the last element of our array and we don't know how many numbers do we have here in our array, so we don't know that the last element index is 9 or 7, if it's 5, etc., because we don't know how many numbers do we have in our array. So this is why it's hard to start with the indexing from left hand side that starts from 0 if we don't know the number of elements. If we know the number of elements, for example, I know that we are having, for example, 10 elements here. I know the last element has the index 9. However, if we don't know the number of elements, or we simply want to access the last element quite fast, we can start from -1, because if we start the indexing from right hand side, starting from the last element, we always start from -1. Like here, that we start always from 0 when we are counting from the left hand side. From the right hand side, it's -1 always. So the last element to be accessed, the index is -1, then 1 to the last is -2, -3, etc., until we reach the beginning of our array. So in order to access the last element of my array, I write down the name of my array. Then I write down the index -1, representing the last element in this array in square brackets. Okay, I write it in square brackets and assign it to a variable called last element. Then I print the last element. So when I run the code, we see that the last element is 100. So we learned that we can have the indexing from right hand side, but we should start from negative numbers. Then the next thing that we are going to learn here is slicing. So in order to learn about slicing, it's like we are extracting a sub array from the original array. So the original array is this array. I would like to have a sub array from this array. Now I would like to have the extraction of this array 1 from index 2 to index 6. Okay, and it is assigned to sub array. So when I run, we see that from index 2 to index 5 is being printed because the last element is exclusive. So index 2 until index 6. So index 2 is number 30. Index 6 is number 70, which is exclusive. Therefore, we are going from 2 to 5. So we are going from 30 to 60. And we see that 30 to 60 has been printed in the output. So we learned that if we want to have a sub-array, we write down the name of the array, then the starting point, colon, the ending point, which is exclusive. So it is going to return the elements from index 2 to index 5 and not 6, because 6 is exclusive, excluded, sorry. Then it is assigned to an array called sub-array, and we print the sub-array here. So the next one is step slicing. The step slicing means that if we want to create a sub-array but with our step. So when I run the code here, we see that we are having 10, 30, 50, 70, and 90. So we are having a step of 2 here, meaning that we are having the first element, not the second element, but the third element, not the fourth element, but the fifth element. Okay, so we are extracting every second element. In order to have such an extraction, we write down the name of the array, then colon 2 in the square brackets. It means that extract every second element. So it extracts number 10, number 30, 50, 70, etc. until the end. And we can change this step. We can change it, for example, so every 3 elements, for example. So 10, 40, 70, as you see here, 10, 40, 70. So every 3 elements, it is going to extract that and assign it to a step array, and we are going to print the step array in the output. Then here we are having the array 1. In order to access, here we learned that we can access the elements using the indexing. So one element can be accessible through here and here, etc. But what if we want to access multiple elements at the same time? Now we can do it using this square bracket inside the main square brackets. So we are having the name of my array, array 1, and then we are having 1, 3, and 5. So it means that we are looking for elements with index 1, element with index 3, and element with index 5. And these are assigned to a variable called multiple elements, and it is holding our elements inside of it. So index 1, 3, and 5 are 20, 40, and 60. 20 index 1, 40 index 3, and 60 index 5. So we are accessing 3 elements that are having indices 1, 3, and 5. In the next Example here, we are going to learn about the Boolean indexing. So when we are talking about the Boolean indexing, it means that we would like to have the extraction of elements based on a condition. So we are here willing to select elements from the array 1 that are larger than 50 and assign it to a new array called greater than 50 and then print it. So when we print these elements greater than 50, we see only the elements that are larger than number 50 is being printed here in the output. Okay, only the elements that are larger than 50, 60 until the end 100. So we see that here we can have the Boolean indexing extracting elements based on a condition, and the condition here is to have a selection of elements that are greater than 50. In the next example, we'll learn how we can modify one specific element in our array. For example, the array within the array, the element in this array with index 2 is 30. You see it here with index 2. In this array 1 is 30. We can have the modification of that element. So index 2, we write it down, the index 2 in a square bracket, then the name of my array. So I write down array 1 in a square bracket, I write down number 2, meaning that I would like to modify the element with index 2 in the array 1 and assign it a new value, for example, 999. And when I run the code and we print the whole array 1, here we see that the third element with index 2, instead of having number 30, it has 999 this time. So we learned how to modify it as well. Then we are having the next operation that we would like to have. So we can have the reversion of the array. So here we would like to reverse the array. How can we do that? We write down the name of the array. Then in square brackets, we are having colon minus 1. Colon minus 1 in a square bracket, helping us to reverse the order. So array 1, the name of my array is in a square bracket, we are going to have colon minus 1, and it is assigned to reversed array. And when we run the code, we see that the array has been reversed, sorry. So we see that here the array starts from 10, 20, 30 until the end, 100. But when we see here in the output, we see 100, 90, 80, etc. until we reach number 10. So we reversed the array as we wanted. So here in this video, we not only reviewed how we can create a one-dimensional NumPy array. This is how we can create it. We reviewed the indexing from 0 from left-hand side. We reviewed the indexing from right-hand side starting from -1, making it easier to access the last element. Then we learned how to access a single element using the indexing of that element. Accessing the last element also we discussed, we can have the -1 being there. Then we discussed about slicing, where we learned how to create a subarray from the original array. So for example, here we learned that we can extract a subarray from the original array that has the elements starting from the index 2 up until index 5, because the last index, which is here the 6, the number 6, the ending index, is exclusive. So it is excluded. Then we learned about how to do the step slicing, meaning that, for example, extracting every second element, every third element, etc. So we learned about that. We write down the name of the array, then colon, and then the step that we're going to have. For example, when we are having the step 2, we're going to have number 10, then 30, and then 50. If we want to have a step 3, it's a third step. The step equals number 3. So we are going to have extracting every third element. It means that we can have number 10 and then 20 and 30 we don't have. Then we are going to have 40, then 50, 60 we don't have. So first, second we don't have. The third we are going to have because we are having the extraction every third element. Then we learned how we can have the access to multiple elements at the same time. We write down the name of the array. Then in square brackets, we're going to have 1, 3, and 5, meaning that we would like to access elements of the array 1 that has the index of 1, 3, and 5. Also, we learned about the Boolean indexing. For example, we would like to extract elements based on a certain condition. Here, the condition was the elements that are larger than number 50. We are having it here. Then we learned how to modify elements in our array. We write down the index in a square bracket and write down the name of our array, and it equals a new number. So for example, 999, meaning that the element with index 2 in array 1 is now equals 999. And then we learned how to reverse the order in an array. We write down the name of the array, colon, -1. Thank you for watching. Welcome back. In today's video, we're going to learn to perform different operations for our two-dimensional arrays. Here is the declaration of our two-dimensional array. We are having three rows here. So row 1, row 2, and row 3. We are having 4 columns, column 1, column 2, column 3, and column 4. So now if I want to make an indexing for this matrix, or let's say two-dimensional array, we can say the index of row is now row index is 0, because we said that we start from 0. Then we are having the row index 1, and then row index 2. So we are having the rows here. Let me make it nicer and more organized. So we are having the rows here. Okay, so we are having 3 rows. Row 1 with index 0, row 2 with index 1, and row 3 with index 2. And we are having 4 columns. So this is the column with index 0. This is the column with index 1. This is the column with index 2, and column with index 3. So here are the 4 columns with index 0, 1, 2, and 3. Here are the indexing of our two-dimensional array. Now we would like to access a single element in this array. In order to do that, we need to write down the name of the array, which is ARR. Then in square brackets, we should mention that the specific number that we are looking for is in which row and which column. So it says that the number that we are looking for is in row with index 1. So this is the row with index 1. And it is in the column with index 2. So column with index 2 is this one, and the row with index 1 is this one that we highlighted in blue. So index 1, row index 1, column index 2, meaning that we are looking for number 70. Okay, so now that we are looking for number 70, we should mention that it is in index 1, row index 1, and column index 2. And when we print it in the output, we see number 70. So the number that is in the row index 1 and the column index 2 from this array called ARR is assigned to a single element, and it is being printed in the output. But what if that I want to report number 110? In order to do that, we should have its row index, which is number 2. Okay, so index of row is 2, and this is the index of column, and column index is 2. And so when we run, we see that number 110 is shown in the output. If I'm looking for the address of number 50, so the row index is 1, so we are going to modify it to 1. Row index is 1, and column index is 0. So I'm going to put this 2 to be 0, and when I run, I expect to see 50 in the output, and you see that this is correct. So this was how we could access a single element in our two-dimensional array. Now we would like to learn how to access a row, an entire row we would like to access it. So here is how we can do it. So we write down the name of the array, which is ARR. In the square brackets, we are having two arguments that are separated by a comma. Before comma is about the row, after comma is about the column. So we would like to have the entire row. So we are going to simply write down the colon, meaning that the entire colon we would like to be, sorry, the entire row we would like to be printed. So we mean that the second row with index 1, the second row with index 1, we want it to be printed entirely. So we write down the name of the index of the row, which is 1 here, and then put a comma and colon, meaning that when we run the code, we see the entire row in this print in the output. The point that I mentioned, that before comma, everything is about the row, and after comma is everything about the column, is making sense for the accessing the element from one two-dimensional array, but not here. This one's when we wanted to retrieve the entire row, we're going to simply write down 1 if we are looking for the second row, which has the index 1, comma, and we put the column, meaning that we want the entire row to be printed. So when I run the code, you see that we are having the entire row, the second row with index 1. If I want to have the row with index 0, which is the first row, when I run the code now, we see 10, 20, 30, and 40. Okay, so instead of this column, put a number, it will become exactly like accessing a single element with this row and this column. For example, if I write down the row index 0, the column index 2, it is going to print me number 30. So when I see the output, you see number 30 is there. But if I want to print the entire row with index 0, I simply write down comma and colon, and we see the entire row is being printed here in the output. So this is how we can have access to the entire row. And in order to have access to the entire column, we can simply write the name of our array, which is ARR, and we start by colon, comma, and then when we would like to print the third row, which has the index 2, we write down the index 2 here. So when I run the code, we see 30, 70, and 110. So 30, 70, and 110. So the third column is being printed with index 2. So we are putting the index 2 here. And because we want it to be entirely printed, we write down colon, comma, and then the index of that column. So if I want to print the entire column with index 1, like 10, 50, and 90, I put number 0 because 0 is the index of this column. When I run the code, we see 10, 50, and 90 here in the output. So this was how we could also retrieve the entire column. But what if we would like to do some slicing and extracting a sub matrix? In order to do that, we are having the name of our original array, which is ARR, and we are having in the square bracket, we are having a comma separating the extraction of the row and the extraction of the column, meaning that now we would like to extract a submatrix for row 0 and 1. So number 2 is there, but it's not being included, the ending point. So 0 and 1 is included. So extract the row 0 and 1 and extract the column 1 and 2. Why not 3? Because 3 is exclusive, so it's excluded, so it's not going to be included. So exclude the rows 0 and 1. So this is row 0 and this is row 1, and column 1 and 2. So when I run the code, we see 20, 30, 60, 70 in the output. So we see index of the rows 0 and 1, so these two rows. And among them, we would like to have column 1 and 2, meaning 20, 30, 60, 70. 20, 30, 60, 70. So this is how we could create a submatrix in our code from the original matrix using this code. So this is what we called slicing. And we assign it to a submatrix, and submatrix is being printed later on. Then in the next line, we could have selection of specific rows or columns, for example. This is called fancy indexing. Here we are selecting the first row and the third row being assigned to the selected row. And when I run the code, we see that for the selected rows, we are having the first row and the last row, the third row being printed. So the first row is 10 to 40, the last row is 90 to 120. So we see that the first row and the third row, which is the last row, is being assigned to a new matrix. So in order to extract specific rows, we write down the name of our array. Then in the square bracket that are shown in yellow, we are having another square bracket here saying that from row, we want row with index 0 and we want row with index 2, and separated by a comma, they separated by a comma, and then we are having column, meaning that the entire row we are looking for. So this is going to extract row with index 0 and row with index 2 and assign it to the selected rows. And here we are printing the selected rows in the output. We could also have another, for example, rows. Instead of rows with index 0 and 2, I would like to have rows with index 1 and 2. Index 1 and 2 are 50 to 120. So when I run, now we see that we are having 150 from 50 to 120. So this is the selected rows. We can choose multiple rows to be extracted. Also, similarly, we could have the selection and extraction of multiple columns. Here, for example, we are trying to extract the second column and the fourth column. So second column, which is having index 1, the second column is index 1, and we are saying about the fourth column which has the index 3. So the second column with index 1 and the fourth column with index 3, we would like to extract only these two columns. We write down the name of the array. First we start with colon and comma, then in a square bracket we specify the index of the columns that we would like to extract, and all of them are assigned to selected columns, and we are printing selected columns. So we see 20, 60, 100, 20, 60, 100, 40, 80, 120, 40, 80, and 120. So the selected columns are extracted and assigned to a new matrix, and that new matrix is being printed in the output. Then we are going to have the Boolean indexing, talking about the extraction of elements based on a condition. So here we write down the name of the array, and the elements that are greater than 50, are going to be assigned to this greater than 50 matrix, and we are printing that out. So the elements that are larger than 50 are being assigned to a new matrix, and that matrix is being printed. So this is how we can have the extraction of our original array based on this condition. So each element that is larger or greater than 50. This is another point. Then we are having the modifying of element. For example, the element in row index 1 and column index 2. So row index 1 and column index 2, which is 70. Now I want to replace this 70 with 999. So when I run the code, we see that this number 70 is not there anymore, it's 999. So in order to do that, I write down the name of my array, then I write the index of that number row that we are looking for, and then the index of that number column that we are looking for, and we are assigning it simply a new value. This new value is then modified in the original array. Then the next one is when we would like to access the last row and column of the original array. So in order to access the last row, again, we can use the -1 or -1 index. And in order to access the last column, we can have the -1 index again to access it. So in order to access the last row, we write down -1, comma, and colon. In order to access the last column, however, we first start with the colon, comma, and then -1. And both of them are assigned to last row and last column matrix respectively. And then we are printing them in the output. Here we see that we are having the last row. The last row is from 90 to 120. So we see from 90 to 120. And we are having the last column from 40, 80, and 120 are being printed in the output using the negative indexing. So in this video, we learned about accessing a single element in a two-dimensional array, or let's say a matrix. We learned how to access an entire row, how to access an entire column, and we learned about slicing, extracting a submatrix from different parts of the rows and columns. We learned about fancy indexing, where we are having the multiple rows being extracted or multiple columns being extracted. Then we had the Boolean indexing, helping us to extract elements based on a condition. We learned about the modification of a single element in two-dimensional array. And also we learned about accessing the last row and column in a two-dimensional array. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to learn how to access elements and slicing in one-dimensional NumPy arrays. So here is my NumPy array. This is how I'm creating the NumPy array. First of all, I am importing the NumPy library as np, so I use np.array. Then these are the elements in the square bracket, the elements that I am initializing for my NumPy array, and it is called array one-dimensional. And these are the elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 elements here. And before we learned about the indexing here for arrays, for example, when we want to have the indexing, we're going to start from 0. Then we're having 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when looking at this, when we're looking at this, we realize that if we are indexing from the left-hand side, we are going to start from 0. So the first element has the index 0, and the last element has the index 9. So if I'm talking about an element with index 5, it means that I'm talking about number 60. So this is what we need to keep in mind. Also, we learned that if we want to label from right-hand side, we are going to have -1. For the last element, we have -2. Then we have -3, etc. until we get to the first element here. Okay, so indexing from left-hand side starts from 0. Indexing from right-hand side starts from -1. Now, we're going to learn how to access elements in one-dimensional NumPy arrays. In order to access, for example, the element with index 3, which is number 40, we write down the name of the array, which is array one-dimensional, and then in square brackets, we are going to write down the index of that element. So if I'm looking for number 40, I need to write down its index, which is number 3. So name of the array, and in square brackets, the index of that element. And this is assigned to a variable called a single element one dimensional. So when I run the code, here I'm having the print of the single element. So I say single element at index 3. And this is the print of the original array. When I print this is the original array, we see it in the output. And the single element at index 3 is 40. We see it in the output simply here. So when I want to access 40, I need to access through its index, which is 3. If I change it to another index, for example, here, if I say I would like to access element at index 5, for example, I revise this number here in the print as well. But here I'm telling the compiler I want the element with index 5 from the array one dimensional array. And index 5, we know that it's number 60. So when I run the code, we see 60 being printed out in the output. So this is how we can access element while we are using the indexing from left-hand side. But it's easier, let's say, to access elements from right-hand side at some point. Why? Because at some point we may need to have the access for the last element. And if we don't know the size of the array, we don't know if it's number 9, number 10, or we don't know how many elements are there, so we don't know how many indexing we need to know about. So this is why when we want to access the last few elements, it's better to use negative indexing, meaning that if you want to access the last element, although you can do it through index 9, but if you don't know about the size of the array, or you need to count it to see, okay, the last element like the way that I did here. So 0, 1, 2, 3 until you reach the last element and see, okay, now it's number 10. Number 9 is the index of the last element. But in order to make it easier, what we can do is to start from -1. When we start from -1 or -1, it means that we are talking about the last element. If I write down -2, it means that I'm talking about the second to last element, third to last element, -3, etc. So in order to access the last element, we simply write down the name of the array, and in square brackets we are going to write down -1. We assign it to a variable called last element one dimensional, and we are printing it here, last element one dimensional here. So we see that the last element, it says 100. So because we used -1 or -1. If I write down -2, we are going to have the second to last numbers, which will be 90. So I have 90 here. If I write down -3 and I run the code, we are going to get 80. -3 is 80. And we know that if we use the left-hand side indexing from the left side, let's say, if we want to access number 80, we can write down index 7. So when I run the code now, we see that indexing from left side it's 80, and from the right side it is 80 as well. Why? Because we either can use the indexing from left side, starting from the left side, or from the right side here. So 7 and -3, they are both talking about specific element that we are having in our array. So this is how we can access different elements of our array. Then let's talk about the slicing. So slicing means that we want to get some part of the array, but not the full array, or maybe we would like to reverse the array. So we would like to work with the array, the original array, and have a sub array, let's say, or maybe we would like to reverse it, we would like to skip some of the elements, etc. So this is what we call slicing. So in this video now we would like to learn about slicing about one-dimensional arrays. In order to do the extraction of the elements of an array, or let's say doing the slicing, we're going to write down the name of the array, which is array underscore 1D. Then in square brackets, we need to mention the indices that we would like to have in the extraction. So this is the starting point, number 2, before colon, which is number 2, the starting point. After the colon, it's the ending point, but it's exclusive. So number 7, when it's there, it is not included, and number 6 is included. So it is going to start from 2 and ends at 6 included. Okay, so it means that I would like to create a new array starting from index 2, ending at index 6, starting at index 2, ending at index 6. So I would like to create an array from 30, 40, 50, 60, and 70, and assign it to slice 1D. And when I print slice 1D, you see exactly 30, 40, 50, 60, 70 is there. 30, 40, 50, 60, 70 is there. So now in order to do the slicing, we simply write down the name of the array, then the starting point and ending point. And we need to keep that in mind that ending point is exclusive. This is one thing. Another thing is that what if we would like to have every second element? So it means that I want 10, then I don't want 20. I want 30, I want 50, I want 70, I want 90, etc. until the end. In order to have this, we write down the name of the array again. Then we write down colon, colon, and number 2 because we would like to have every second element. And this is what called step slicing. So we are assigning the new array which has the every second element of the original array. We are calling it a step slice one dimensional, and we are printing it here. So we see 10, 30, 50, 70, and 90. If we would like to have every third element, we could simply write down 3 here. So we are going to have 10, 40, 70, 100, 10, 40, 70, and 100. So it depends what we are looking for, but this is how we can do step slicing. And finally, if we would like to have the reverse of the array, we can write down the name of the array. Then in square brackets, we are going to have colon, colon, minus 1. When we are having colon, colon, minus 1, simply we are reversing the array, meaning that we are telling the compiler, okay, start the array from the right side, meaning that from 100. And this new array that we are creating, we are reversing from the original array, is assigned to reversed one-dimensional array. This is the name that we choose. And when we are printing it here, we see that we are having a reversed array being shown here in the output. So in this video, we learned how to access elements and different type of slicing in one-dimensional NumPy arrays. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to work with two-dimensional arrays when we would like to access its element, and when we would like to do slicing for two-dimensional NumPy arrays. So here is my two-dimensional array. We see that it has 3 rows, row 1, row 2, and row 3, and it has also 4 columns here. Let me label the rows and columns. So this is the first row with index 0. This is the second row with index 1. And this is the third row with index 2. So again, we are going to start from index 0. With respect to the columns, this is the first column with index 0. This is the second column with index 1. This is the third column with index 2. And this is the fourth column with index 3. So if I make it a bit nicer and organized, I think it would be easier to see it. So now, okay, and a bit to the right. Okay, now I think it's better. Okay, great. So now we see that we are having 3 rows with index 0, 1, and 2, and we are having 4 columns, sorry. So this is the first column with index 0, second column, third column, and fourth column. Now, if we would like to access a specific element, how can we do that? Simply we write down the name of array, which is a_r_2d. Then in square brackets, we are going to write down the index of the row and the index of the column. For example, I want to access number 70. In order to access number 70, I need to give its address to the compiler based on the row and column. So number 70 is in the second row which has the index 1. Okay, index 1 for the second row for number 70. So here we are going to put the number 1 because it has a row with index 1. Okay, now I need to give address to its column. We see that number 70 is in the third column which has the index 2. So we are going to write down index 2 here as the column index. Therefore, we simply write down the name of the array, write down the index of the row, comma, and the index of the column. So what we mean here is the following. If I want to access number 70, I need to tell compiler go to the array 2d, then go for the row with index 1 and column with index 2, you're going to find that number. And when you found that number, assign it to this variable single element two-dimensional, which we are printing it here in the output. So when I run the code, we see that number 70 is being printed in the output. If I wanted to access another number, for example, if I wanted to access number 100, I should have written indexed for the row, which is 2. So I write down index 2 for the row, and for the column I write down index 1 because number 100 is in the third row which has the index 2, and it's in the second column which has the index 1. Therefore it is going to have the index 2 for the row and index 1 for the column. So when I run, we see that number 100 is being printed in the output. So we need to simply give the correct address and everything is taken care of. So here I was printing that number 70 using this line, and before that I was printing the original two-dimensional array. So this is the original two-dimensional array. We're printing it in the output, and then I am here accessing the specific element which is number 70, which appears in the row with index 1 and column with index 2. Okay, now what if I want to extract the first row only? So we are kind of doing the accessing and slicing. Maybe it's a combination of both of them. We would like to have a new array, let's say, that has only the first array, the first row of our original array. In order to do that, I write down again the name of the original array. Because I would like to extract the first row has index 0. So I write down 0, comma, and colon, meaning that I want to extract the entire first row. Okay, and it is assigned to first row array, and we are printing the first row here, and we see that the first row is 10, 20, 30, and 40. So 10, 20, 30, and 40. The first row is only being printed in the output. We could have the print of the second row, for example, a second row which has the index 1. When I put number 1 here, I run the code, and we see that the second row here is 50, 60, 70, and 80. Okay, so depending on what we are looking for, we can modify the numbers here in square brackets. And if we want to extract the last column, so this is the last column, we write down the name of the array, and in square brackets we are going to have colon, comma, and -1. -1 is going to take the last column of the original array. Or we could simply write down the column with index 3. Both of them are having the same results. So when I run the code, we see that the last column is 40, 80, and 120. So instead of having -1, now I decide to have the index 3, which is here. So when I run, you see again 40, 80, and 100. But -1 is easier to have it there, but it depends on you. I'm more comfortable with -1, so I would leave it that way. So we are extracting the last column of the two-dimensional array and assign it to last column array, and last column is being printed here simply in the output. So now let's talk about slicing. Now we are having the slicing of our two-dimensional array. So I would like to extract rows 0 and 1, so rows with index 0 and index 1, and columns of index with index 1 and 2. So rows with index 0 and 1, these are two rows with index 0 and 1. Then columns with indices 1 and 2, meaning that this is the column with index 1, this is the column with index 2. So we are going to have 20, 30, 60, and 70 only. Why? Because we are having the first two rows, and then we are having the column with index 1 and index 2, and not 3 and not 0. So it means that I would like to have a new two-dimensional array which contains 20, 30, 60, and 70. Okay. In order to do that, first I need to extract these four elements from the original array. I write down the name of the array, then in parentheses, in square brackets, I separate them, their rows and columns with a comma. So before comma, I'm talking about the rows. I would like to have rows with index 0 and 1. So the starting point, as always, is inclusive, and the ending point is excluded. Therefore, we are going to have the rows 0 rows with indices 0 and 1. So the starting point is 0, but the ending point is 2 because 2 is excluded and it is going to go up to 1 included. Okay, so rows with indices 0 and 1, and before comma and after comma, because we are looking for column 1 and 2 with indices 1 and 2. Here we are going to have the starting point, which is included, to be 1, and the ending point to be index 3. Why? Because it is excluded and it is going to go from 1 and finishes at 2. Therefore, we are starting from row 0 and ending at row 1. Then we are having the column starting with index 1 and ending with index 2 from the original array named ARR_2D. And it is assigned to a new two-dimensional array called submatrix. And simply we are printing the submatrix here. So this is the submatrix. We see that 20, 30, 60, and 70 that we were looking for, 20, 30, 60, and 70 is being printed here in the output. Very nice. And finally, if we would like to have, for example, the print of every second column, we can write down the name of the array. We're going to have colon, comma, then colon 2 is going to give us every second column. So when I run the code, we see that every second column is 10, 50, 90, 30, 70, 110. 10, 50, 90, 30, 70, and 110. If I want to have every third column, when I run the code, I put the number 3 here and I run the code. It's 10, 50, 90, but this time it's 40, 80, 100, 10, 50, 90, and 40, 80, and 120. You see? So every third column. If you want, you can change it also, but you can also have only column here, but here you can have for example, every second row. Every second row means that the first row is going to be there and the last row is going to be there. It's like 10, 20, 30, 40, 10, 20, 30, 40, and 90, 100 until we go to 910. Therefore, depending on what we are looking for, we can modify this, of course. So we learned also how to have every second column and every second row as well. So in this video, we learned about indexing and slicing for two-dimensional arrays. We learned that we are going to have indices starting from 0 for the rows and also for the columns. Then we learned that when we would like to access one specific element, we need to give its address based on the row index and the column index as well. To the compiler, we learned that we can extract the entire row or the entire column. Also, we learned how to have, for example, multiple rows being extracted from specific columns. Here in the output, we see them. Also, we learned about the slicing of every second column, for example, or every second rows. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to learn about how to work with three-dimensional NumPy arrays. So in this video, we're going to learn about three-dimensional NumPy arrays, specifically accessing elements, also to have the slicing. So first of all, we are having the example of a three-dimensional array. So this is the layer 1, this is the layer 2. So let me do the indexing here as well. So this is the row. This is the first row with index 0. This is the second row with index 1. This is the third row with index 2. Okay. And also here in the other layer, we are going to have the same thing. So the first row with index 0. We're having the second row with index 1. And also we are having third row with indexed 2. So we are, and this is the layer 1. Let me print it here, layer 1. And this is the layer 2. Also, let me put the indices for the columns. So this is the first column with index 0, index 1, index 2, and index 3. If we make it a bit nicer, it would have been better. So let me organize it a bit. So now it's much better. We see that we are having 4 columns with index starting with index 0. So index 0, index 1, index 2, and index 3. Again, we are going to have the same thing here as well. So we are having the with index 0, index 1, index 2, and index 3. So this is our three-dimensional NumPy array. We are having 2 layers. This is the first layer. This is the second layer. And in order not to mix the details, it would be nice to label them like just like what I did here. So you say first row, index 0, second row, index 1, third row, index 2, for example, and the columns. And also you label the layers, layer 1 and layer 2. Now, I would like to access one element, one specific element in this three-dimensional array. Say, for example, I would like to access number 24. First of all, I need to write down the name of the array. So we see that here I'm writing down the name of the array. Then in square brackets, there are 3 parts separated by 2 commas. So the first one is the index for the layer. The second one, index for the row. This is the index for the column. So this is the layer 1 with index 0, and here this is the layer 2 with index 1. Okay, so I would like to access number 24. First of all, I write down the name of the array, which is ARR underscore 3D. Then in square brackets, I type down the index for the layer. So number 24 is in layer 2, which is having the index 1. So I write down index 1. Then I write down the index for its row. So this is the first row, second row, and the third row. Third row has the index 2. So 24 is in this row. So I write down number 2 here. Then I need to write down the index for the column. So number 24 is in the fourth column, which has the index 3. So this way, the compiler is going to go for this array for layer with index 1, row with index 2, and finally column with index 3. And that specific number is going to be assigned to single element 3D. And when I run the code, we see that number 24 is exactly being printed in the output because I'm using the print function. First of all, I print the original array, then I print the single element that we were looking for, number 24. Okay? In order to make another example, what if I want to access, for example, number 19 here? So first of all, I'm going to write down the index for its layer. And we can see that the layer index is 1, therefore we write down number 1 as the first one. Then the row index is 1, so the row index is 1. I write down number 1 here because 19 is in the second row with index 1, and it is in the third column with each has the index 2. Okay, so this is the number 19 with index 2. So when I run the code, we see number 19 in the output. Okay, so basically we can access any element that we are looking for. We can access any element that we are looking for, but we need to be careful about the indexing of the layers, rows, and columns. And it's very important to know that you need to write down the index of a specific row or column, for example, or layer. Not that, for example, when we are having the second row, it's the second row, but the index is 1, it's not 2. This is something to be very careful about. Then we would like to extract the second row for all the layers. So the second row of all the layers, so this is the second row in the first layer, this is the second row in the second layer. I would like to extract that. So this one along with this one. So I write down the name of the original array, and in square brackets, first we are going to have the layer part, it's colon, comma, the part that is for the column, it's also colon again. So here in the middle that we were talking about the rows, we're going to put number 1. Why? Because the second rows, they are having index 1. Index 1, meaning that take everything from the second rows of both layers. Okay, so for the layer I put colon, for the column I put colon also. Therefore the only one that is there is number 1, meaning that take all the second rows because number 1 is index of the second row. So when I run the code now, you see that these two rows are printed starting with 5 and 17. Starting with 5 and 17. So it is extracting all the numbers in the second rows in both layers. If I have, instead of this, if I write down number 0, it means that extract all the first rows in both layers. So when I run the code, we should see something starting with 1 and with 13. So we see starting with 1 and 13, you see? So this is how we can extract, for example, the second row from all depths, let's say, or the layers. We could have in here column, and here we could have the, for example, number 1. So when I run the code, you see that here we are printing the uh, the uh, the second column of all layers. So both layers. We see that, for example, number 1 is there. And when we go to the output, we see that 2, 6, 10, 14, 18, and 22 is printed. So 2, 6, 10, and 14, 18, and 22 is being printed, meaning that print all the elements from the second column of both layers. You see? So second column, because the column with index 1 is the second column. So 2, 6, 10, 14, 18, and 22 from both layers printed in the output, and we see exactly the same thing. If I wanted to have, for example, another column to be printed, I could say, for example, if I wanted to have the fourth column with index 3 from both layers, when I run the code, I put number 3 here, so it is going to print 4, 8, 12, 16, 20, 24. So you see 4, 8, 12, 16, 20, and 24 is being printed in the output. So the last column in both layers are being printed in the output. So this is how we could extract a specific row or column number from both layers. Now let's talk about how we can extract, for example, specific columns and rows at the same time. So here we are extracting columns 1 to 2 from all rows and all layers, meaning that the extraction of the columns 1 and column 2, column 1 and column 2 from both layers and all the rows, okay, all the rows. So when I run the code, you see that here we are having 2, 3, 6, 7, 10, 11. So 2, 3, 6, 7, 10, 11, and then 14, 15 until 22, 23. So 14, 15 until 22, 23. So we are basically printing all the rows and all the layers for column with index 1 and column with index 2. And as always, the starting point is included, the ending point is excluded. So when we want to have the rows with indices 1 and 2, we write down from 1 to 3. Okay. And for all the rows, we put column. For all the layers, we put column. From the array called ARR_D, it is assigned to slice_D. So the name of the new array is slice_3D, and we are printing out it in the output. You see here, we are printing it in the output, and we were seeing it here. So this is how we can have the extraction of, for example, 2 columns from all the rows and all the layers. And finally, if we would like to extract, for example, every second row and every second column for both layers, because we would like to have for all layers, we write down the colon here separated by a comma. Then here every second rows, colon 2, comma, every second column, colon 2. So this is going to create a new matrix for us for every second row and every second column in both layers. Basically, every second row is this and this, and every second column is this and this. Okay, and here again this and this and this and this. So when we see the output, we see 1, 3, 9, 11. So this is 1, 3, 9, 11. So every second row, the first row and the third row, and every second column, so this column and this column. So 1, 3, 9, 11, and we expect to see 13, 15, 21, 23 as well. So we see 13, 15, 21, and 23 as well. So in this video, we learned about three-dimensional arrays in Python using NumPy library. We learned how we can have the access to one specific element or the one specific row in one layer or both layers, and we learned about the extraction of, for example, two columns, and also we discussed about having the every second row and every second column in both layers. Thank you for watching. Hello everyone, welcome back to this video. In today's video, we're going to talk about creation of one-dimensional array, Boolean indexing, fancy indexing, and iterating through a one-dimensional array. So here is my one-dimensional array. It has 10 elements. You see it here. Now I would like to have the Boolean indexing, meaning that we are going to extract elements that are, for example, greater than 50. In order to extract these elements, we write down the name of the array. Then in square brackets, we mention that each element in this array that is larger than 50 is assigned to a new array called greater than 50, and here we are printing it out in the output. So we see that the elements that are greater than 50 are the following: 60 until 100. So here, using a Boolean indexing, we learned how to extract elements that are greater than 50. We could also have, for example, greater than 60, for example. So if I run, we see as of 70 is being printed here. So greater than 60 are the 170, 80, 90, and 100. We could have, for example, lower than 60, for example. And here we're going to have these numbers in the output in the new array: 10, 20, 30, 40, and 50. So depending on what we are looking for, we can modify this. Also, with respect to the fancy indexing, we can have selecting elements at specific positions. For example, now I would like to, this is my original array. I write down the original array name. I would like to select elements at indices 1, 3, 5, and 7. So let me start indexing this one. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I would like to select elements at indices 1, 3, 5, and 7. So 1 is number 20, 3 is 40, 60, and 80. So I would like to have them. So I write down the name of the original array, and in square brackets, we write down 1, 3, 5, 7, separated by commas. Then it is assigned to a new array called fancy indices. So when I print the fancy indices, we see 20, 40, 60, 80 as we expected is printed there in the output. So this is also very nice to have the possibility to access multiple elements in one line instead of having multiple lines. In each line we are having the access to only one element. Okay, so this is how we can access multiple elements. We call it fancy indexing. And also, in order to iterate through the array, we can show this message first of all, and then we have the iterating variable called value. And we are saying that for each value in our array, one-dimensional array, print the value. And here we see that we are having everything of the original array being printed. And this end means that print everything in one line and also provide one space between for each iteration. So in this video, we learned how we can create a one-dimensional array. We learned about Boolean indexing for conditions that we would like to check. For fancy indexing, we learned how to have access to multiple elements, and also we learned how to iterate through the array. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn about arrays operations. We're going to learn about addition, subtraction, multiplication, division, exponentiation, and using the modulus operator to find the remainder of a division. So this is my first array called ARR1. I call it for simplicity array1 and array2. This is my second array. Each of them is having 5 elements. 10, 20, 30, 40, 50 are the elements of the first array, and 2, 4, 6, 8, and 10 are the elements of the second array. Now I would like to create a third array that is the result of addition of these two arrays. So I have array1 plus array2. It is going to create a new array called addition, and this addition has the first element equals to 12. How come? So 10, the first element of the first array, the first element of the second array, which is 2. So 10 plus 2, it's 12. 20 plus 4, it's 24. 30 plus 6, it's 36. 40 plus 8, it's 48. And 50 plus 10, it's 60. So this is how we are creating the addition array. And then here we are printing it out. So when I go in the output, we see that exactly what we expected is in the output. So 12, 24, 36 until 60. We see 12 until 60 here as we estimated. Then for doing the subtraction, we are having the first array being subtracted from the second array. So 10 minus 2 is 8. We see that array 1 is being subtracted from the array 2, and the result is stored in subtraction array called subtraction. And here in the output, we see 10 minus 2, it's 8. 20 minus 4, it's 16. 30 minus 6 is 24. 40 minus 8 is 32, and 50 minus 10 is 40. So this is what we expect to see in the new array called subtraction, and when we print it, we see the same numbers: 8, 16, 24, 33, 32, and 40. So this is how we can create a new array by subtracting two original arrays that we have here. Then let's talk about multiplication. We have array 1 multiplied by array 2, and it is assigned there. The output is assigned to a new array called multiplication. So this is something to keep in mind. It's element-wise operation. So element-wise multiplication, element-wise subtraction, and element-wise addition, etc. So it's element-wise when we are working with two arrays and we are dealing with the operations. So array 1 multiplied by array 2, meaning that the first element, element-wise, yeah? So the first element and the first element, 10 multiplied by 2, it's 20. We see it here. So 20 multiplied by 4, it's 80. 30 multiplied by 6, it's 180, etc. Until the end, we are creating the array that is called multiplication. And when we see the output, we see exactly the same output here: 20, 80, 180, 320, and 500. So this is the third operation. Then the next operation is the division. Again, here we are also having the element-wise division. So 10 divided by 2, for example, 20 divided by 4. So the array 1 is divided by array 2, and the result is assigned to a new array called division. So we are having 10 divided by 2, it's 5. 20 divided by 4, it's 5. 30 divided by 6, it's 5, etc. until the end. So we are creating the new array called division, and we see the division in the output is this array. So element-wise division: 40 divided by 8, then 50 divided by 10, etc. And exponentiation, we are having it here. So raising elements to a power. So for example, here I'm raising the elements of the first array to the power of 2 and assign the result in the new array called exponentiation. and we are printing the exponentiation. Basically, it means that the first array, which is this one, its element is being raised to the power of 2. So 10 to the power of 2, it's 100. 20 to the power of 2, it's 400. 30 to the power of 2, it's 900, etc. We continue. And we see in the output we are having the exponentiation array containing 5 elements, 100 from 100 to 2500. So we see that the arrays are being raised to uh, power of 2. We can have the power of 3 instead of 2, for example, here. So when I run the code now, we see that the output is changing to the power of 3. Or we can have the array 2 to the power of 3, for example. So the elements of the array 2 are being raised to the power of 3. So we are having 8, 64. 8 is because 2 to the power of 3 is 8. 4 to the power of 3 is 64, etc. until the end. So depending on what we are looking for, we can modify it as always. And finally, working with the modulus operator, it's also an element-wise remainder, meaning that here I'm having the array 1 divided by array 2, and we are caring about the remainder of this division, meaning that, for example, 10 is divided by 2, and the remainder of this division is what number? Modulus operator is going to help us to find that number. So 10 divided by 2, the remainder is 0. This is why we are having 0. Okay. 20 divided by 4, the remainder is 0. So everything is 0 because they are divisible. So these numbers, the numbers in the first array are divisible to the numbers of the second array. But here, instead of having 10, if I have 11, for example, so 50 divided by 11, the remainder is not 0. The remainder is 6. Okay, you see? So modulus operator is going to help us to find the remainder of a division. So if 50 is divided by 11, the output will be a number, but the remainder is 6. Okay, so this is how we can deal with uh, operations that are related for arrays. We learned about addition, we learned about subtraction, we learned about multiplication, division, exponentiation, and modulus operator. And something to keep in mind is that all of them are element-wise operations. So element-wise addition, meaning that the first element of the first array is being added to the first element of the second array. Second element of the first array is being added to the second element of the second array, etc. until the end. Thank you for watching. Welcome back. In today's video, we are going to talk about broadcasting with Scholar. So first of all, I am creating one array. Here is my array. It has 3 elements, 10, 20, and 30. So these 3 elements are the elements of my array called array underscore 1D. Then we are having a variable called scholar, and its value is 5. I would like to add this number to all the elements of this array. This is what we call broadcasting, let's say, or we say that the scholar is going to stretch to match the shape of our array. In order to do that, when I run the code, we see in the output we are having 15, 25, and 35, while we are having 10, 20, and 30 here. So we see that each element is being added with number 5. Okay, so 10 is added, 5 is added to 10, so the output is 15. 20 is added to 5, so the output is 25, and 30 is added to 5, so the output is 35. And here, basically what we are doing is the following. We write down the name of the array plus the name of the variable, the scholar, meaning that each element of this array is going to be added with the scholar variable. And the result is going to be stored in a new array called result underscore 1D. Okay. And finally, we are printing the result 1D array in the output, meaning that here there are 3 elements in my original array, and I have a variable called scholar. It has a value of 5. And when I add them to each other, to create the new array, we see that each element of the original array is being added with this value. So if I have, for example, number 2 here, when I run the code, we see that 10 plus 2 is 12, 20 plus 2 is 22, 30 plus 2 is 32. So this is the name of the array plus scalar variable and stored in the new array called result. So in this video, we learned how we can broadcast a one-dimensional array with Scholar. Thank you for watching. Welcome back. In today's video, we are going to work with broadcasting with one-dimensional and two-dimensional arrays. My original array is called array two-dimensional, and it's a two-dimensional array. It has 2 rows and 3 columns. So 1, 2, 3, the first row, and the second row is 4, 5, 6. Then I'm having a one-dimensional array here that has 3 elements called array one-dimensional row, and it has 3 elements that are 10, 20, and 30. So these are the 3 elements of the second array, which is one-dimensional. Now I would like to add this to this. So the first array to the second array. Okay, the two-dimensional array added to the first to one-dimensional array. So when we are adding this, it means that each element of the first array is going to be added with the representation of its counterpart in the second array, let's say. So, for example, the number 1 is added with number 10, so we are having 11 in the output. Also, number 4 is added with number 10, it's 14 in the output. Okay, so the first column is added with the first column. Number 2 is added with 20, so it's 22. Number 5 is added with 20, so it's 25. So the second column is added to with the second column. The third column is added with the third column. So 3 plus 30, it's 33. 6 plus 30, it's 36. So we see that here in the output, we are having the addition of these 2 arrays, and they are assigned to an array called result two-dimensional. So in this video, we learned that if we are broadcasting with one-dimensional array and two-dimensional array, each column is being added to each other. So the first column is added to the first column of this one. So 1 plus 10, 4 plus 10. 2 is the second column, so it is going to be added to the second column. 2 plus 20. 5 plus 20, it's 25. So 3 plus 30, 6 plus 30. We see 33 and 36 in the output. So when these two are added to each other, we are assigning the result to a new variable, or let's say we are creating a new array called result, and we are printing it in the output. So we see it here in the output. Thank you for watching. Hello and welcome to this video. In today's video, we are going to learn about element-wise operations. Here we are having 2 NumPy arrays. The first one is called A, the second one is called B. Here is my array A. It has 6 elements, 1, 2, 3, and 4, 5, 6. And here is my array B, which has again 6 elements, 10, 20, 30, and 40, 50, and 60. So these are the arrays that I just initialized now, and I would like to first of all see these 2 arrays. So when I run the code, we see these 2 arrays in the beginning of the code. So let me comment this part. So we only see the arrays. Oops. Okay. So when I run the code one more time, we see that this is array 1. This is the first array, which we call array A or matrix A. This is the second array, and we call it matrix B. We see that array A has 2 rows and 3 columns here. So 1, 2, 3, first row, 4, 5, 6, second row, 1, 4, first column, 2, 5, second column, 3 and 6, third column. The same goes with the second matrix, which is called B. Now we would like to perform some element-wise operations. Here, first of all, we want to do the element-wise addition. So we are having the add function, and inside parentheses, we need two arguments. So, and they are separated by a comma. The first one is the first array. The second one is the second array. So add, we are adding A and B. The array A and B, they are being added to each other element-wise. So after having these two arrays being added to each other, we are assigning the output in a new array called C underscore add. And here, using the print function, we are printing the C underscore add array in the output. So when I run the code, now we see the element wise addition here. So we are having the A plus B. We see that the first element is 11 and it comes from 1 being added to 10. So the first element in the first row and the first column of the first matrix is being added to the first element in the first row in the first column of the matrix B, and it is 11. Then we are having 22. It means that 2 is added with 20. So it's element wise. Okay. 3 is being added to 30 and it's now 33. 4 being added to 40, it's 44. 5 being added to 50, so it's 55. And 6 is being added to 60, it's 66. So it's the element-wise addition of A and B matrix A and matrix B, or let's say array A or array B. Now that we learned how to do the element-wise addition, we are going to do the element-wise subtraction. This time, we are going to call the subtract function, and in parentheses, we are having A and B again separated by a comma, and the result is assigned to an array called C underscore sub. And when we print this array, when I run the code, we see that this is my new array, which is the element-wise subtraction. So we are having -9, -18, -27, -36, -45, and -54. But how? So here we see that this is the first array and this is the second array. And we are reducing, for example, this element 1 is -10. So 1 minus 10 here, 1 minus 10, the output is -9. And we see -9 here, okay, or -9. We see here, we see number 2, the second element in the first row and the second element in the first row here. So 2 minus 20, the output is -18, and we see 18 here in the output. Then we are having, for example, the third element of the first row, 3 minus 30, 3 minus 30, it will be -27. So we see it also here in the output. So this is how the element-wise subtraction is done over the A minus B. So we are writing down A minus B. This is why we are having the A as the first element. If I was writing, for example, B and A, so when I run the code, we see that the results are different because now B is being reduced from A. So 10 minus 1, it's 9 now. 20 minus 2, it's 18 now. Okay, so this is how we can proceed with the subtraction. The first array, we can call it A. The second array, we can call it here in parentheses B. So A is going to be subtracted from B. But if we want the other way around, we need to write down B in the first part of the parentheses before the comma. So what I mean here is the following. So A, when we are having A and B, it means that A minus B. But when we are having B and A, it means that we are having B minus A. Depending on what we are looking for, we need to be careful about the order in which we put the name of the arrays. Then we are having the element-wise multiplication. We call the multiply function, and we are having a and b in the parentheses, and we are assigning the output in the c_mul. And when I run the code, we see that matrix A is multiplied by matrix B, and the output is here. For example, we are having 1 multiplied by 10, this is 10. We are having 2 multiplied by 20, this is 40. We are having 3 multiplied by 30, and it is 90 here. We are having 4 multiplied by 40, it's 160. We are having 5 multiplied by 50, it's 250, etc. until the end. So this is the element-wise multiplication that we use, multiply function. Then we are having the element-wise division. We call the divide function. And in parentheses, we again write down the name of our arrays, and the output is assigned to c_div or div, and we are printing this newly assigned array in the output. So we see that here we are having the result of element-wise division, a divided by b. So we see 1 divided by 10, it's 0.1. We see 2 divided by 20, it's 0.1, etc. until the end. So element-wise division we are having here using the divide function. And here we are having the broadcasting with one-dimensional array. So we are having a new array called C, and it has 3 elements, 1, 2, and 3. And we are simply printing the C in the output. So we see the C. Now we would like to do broadcasting and adding C to A. So this is the array C. We would like to add it to array called A. And we're going to use the add function that we learned here. So when I run the code now, we see that the output of this operation is here. So array A is having 1, 2, 3, 4, 5, 6, and array C is having 1, 2, 3 only. We see that we are going to have an array that is two-dimensional, and the first element is 2, meaning that 1, this first element 1 is being added to this one, so it becomes 2. And then this number 2 is being added to this number 2, and it becomes 4. 3 is added to this number 3, and it becomes 6. So this is how we are calculating the first row. And the second row, similarly, we are having 4 being added to 1, it's 5. We are having 5 being added to 2, it's 7. We are having 6 being added to 3, and it's 9 as we see it here. So we created a new array here called C, and we basically added A and C and calculate the output, and we are assigning the output to c_broadcasted add array. Then we can also have the multiplication, for example, of C and A. So we use the multiply function to have the multiplication of A and C, which is element-wise. So we are having 1, 2, 3, and 1, 2, 3. So 1 by 1, 1 multiplied by 1, it's 1. 2 multiplied by 2, it's 4. 3 multiplied by 3, it's 9. So 4, 5, 6 are here. So we see that when we are having 4, 5, 6, 4 multiplied by 1 is 4, 5 multiplied by 2, it's 10, and 6 multiplied by 3, it's 18. So we see that we are having the element-wise multiplication here as well. So in this video, we learned about element-wise operation. We learned how we can use the element-wise addition, element-wise subtraction, element-wise multiplication, element-wise division, and also we added a new array here, and we added that new array to the existing array called A, And also we calculated the multiplication of these two arrays, A and C, and we saw the result in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to review some mathematical functions. Here is my NumPy array. It is called X. It has 4 elements, 0, 4, 16, and 25. Now we would like to have, first of all, the print of my array. So I write down the print function and I print the function called X. And this is the message that we are showing here. So this one is extra. We remove it and we run the code. We see array X is 0, 4, 16, and 25. So 4 elements. First of all, we would like to calculate sign of X. In order to calculate the sign of X, we simply write down the sign, sin function, and in parentheses, we are having the X being there. So this is going to call the sign function to calculate the sign for each element of this function. And it is assigned to an array called sign underscore X. And we are printing out the sign X in the output. And we see that the output, for example, here, the sign of element, the first element, which is 0, is 0. The sign of number 4 is negative 0.75. We are having the sign of number 16, which is negative 0.28, and we are having the sign of number 25, and we see that it is also negative 0.13. So this is how the compiler is going to calculate the sign of all the elements that are inside the array called X. Then if we would like to calculate the cosine, we simply call this function, and inside parentheses we write down again the name of our array, which is X, and the output is assigned to cosine underscore X, and we are printing that array in the output. When we run the code, we see that, for example, the cosine of 0 is 1, the cosine of number 4 is this number, the cosine of 16 is this number, and the cosine of 25 is this number. Then we would like to compute the exponential of each element, meaning that e to the power of x, and we are seeing that we call the exponential function exp, and in parentheses we simply write down the name of our array. The output is assigned to this again, exp underscore x, and we are printing it here in the output. And we see that the exponential of element, the first element 0, is this number. The exponential of the second element, which is 4, is this number. The exponential of number 16 is this number, and the exponential of number 25 is this number. So we see it in the output. Then we would like to find the square root of the elements that are in our array called X. So we call the square root function sqrt. And we see that the square root of 0 is 0, the square root of 4 is number 2, the square root of 16 is number 4, and the square root of 25 is 5. So in this video, we learned how to apply certain mathematical function for a NumPy array. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about mean, median, variance, and standard deviation. We are going to learn how to calculate them for a NumPy array. So here is my NumPy array. It has these elements 1, 3, 5, 7, 9, 11, 20, and 50. And the name of my array is X. First of all, for the reference, I print this array. So we see it here in the output. This is my array. Then in order to calculate its mean, we are going to have the mean function for the array X, meaning that we are going to calculate the mean or the average value among the elements of the array X. And we assign that output to the mean underscore X variable, and we print that in the output. So when we look at the output, we see that the average or the mean of the elements of my array called x is 13.25. So the average of these numbers is 13.25. So we call the average the mean function to calculate the mean, or let's say the average. Then in order to calculate the median, we call the median function to find the median value in the array x. We assign it to a new variable called median underscore x, and we are printing that in the output here again. So here we see that the median number is 8. It means that the middle value when we sort this array is number 8. As you see, this is the part where we can insert the number 8, the blue part. So exactly we are having 4 elements before that. We are having exactly 4 elements after that. So this is the median of my array called x. Then we would like to calculate the variance. In order to calculate the variance for the elements of the array x, we call the var function for the array x, and we assign the output to this variable, and we print this variable in the output. So we see that here is the number of variance 222.68. This is the variance of the elements that we are having in the array called x. And then in order to calculate the standard deviation, which is also the square root of the variance, we call the std function for the x array for the elements of the array x. So this way we are calculating the standard deviation of the elements in the array x. We assign it to this variable std underscore x, and we print it here in the output. And we see that the standard deviation is this number, approximately 14.92 is my standard deviation, which is also the square root of the variance, which is this number. So far we learned how to calculate the mean, or let's say the average, the median or the middle value, the variance, and the standard deviation of a one-dimensional array. Now let us have a two-dimensional array. So it is called y, and this is my two-dimensional array. For the reference, I printed here in the output, so we see that this is my array that is two-dimensional. So this is the first row, second row, the third row, first column, second column, and the third column. Now I would like to have the column-wise average or column-wise mean. I mean that, for example, 1, 10, and 5. I would like to calculate their average, 1, 10, and 5, all the numbers in the first column. This is what I mean when I say column-wise. So the mean of the first column is this number. Then we are having the second column 2, 19, 27. The mean of the second column is this number. And the mean of the third column, 3, 5, and 18 is this number. But how can we do the column-wise mean? So we call the mean function for the y array, that is our two-dimensional array, we are having axis equals to 0, meaning that we would like to have the column-wise mean, and we are assigning it to this variable, and this variable is being printed here in the output, which is itself a one-dimensional array. So now we would like to have, in the next step, we would like to have the row-wise mean. It means that this is the first row. I would like to have the mean of the first row. This is the second row. I would like to have the mean of the second row. And this is the third row. I would like to have the mean of the third row. So the calculation of the mean of the first row is number 2. The mean of this row is approximately 11.33. And the mean of this row is 16.66. In order to have the row-wise mean, we are having the mean function for the y array, and we put the axis equals 0. It means that we are telling the compiler that do the row-wise mean. Okay, so when axis equals 0, it's column wise. When axis equals 1, it's row wise. Now we would like to calculate the standard deviation along the x-axis, meaning that we are looking for a column-wise standard deviation. So this is why we are calling the std function for the y-array, and we are assigning axis equals to be 0. So this is the column-wise standard deviation. So column-wise standard deviation means that the standard deviation of the first row, standard deviation of the second row, standard deviation of the third row. So the standard deviation of the first row, first column. So the standard deviation of the first column, second column, and third column. So we are having the standard deviation of the first column 1, 10, 5. The standard deviation is this number. Then 2, 19, 27, this is this number. And then 3, 5, 18, this is the standard deviation of this column. Okay. Now, in the next stage, we would like to have the variance, row-wise variance. We are calling the var function for the y array, and we are having axis equals 1, meaning that this is the row-wise variance calculation. So the row-wise means that the variance of the first row, the variance of the second row, the variance of the third row. So the variance of the first row is this number, the variance of the second row is this number, and the variance of the third row is this number. Basically, in this video, we learned how to calculate mean or average, median or middle number, and standard deviation and variance for one-dimensional array and two-dimensional arrays. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to learn how to find the minimum number, maximum number, and their indices for our NumPy array. So here is my NumPy array. It is called X. It has these elements 10, 25, 3, 58, 42, 7, and 18. First of all, for the reference, I just print the array here in the output. In order to find the minimum number among the elements of this array, I call the min function and I write down the name of my array to find the minimum element in my array, and we assign it to min underscore x and we print min underscore x. So when I look at this, we see that number 3 is the minimum. So let's see what's the output. So we see that using the min function, we could find the minimum element in our array, which is number 3. Then, in order to compute the maximum number in the array, we see that, okay, here the maximum number is 50, if I'm not mistaken, but we can do it also using the max function. So the maximum number in the x array is assigned to this variable called max underscore x, and we print this variable. We see that number 50 is shown in the output. Now let us work with the indices. So let me review something here first of all. So we know that the indexing here starts from 0. So the first element has the index 0, the second element has the index 1, then index 2, 3, 4, 5, 6, and 7. Here we can also work with the indices of our elements. For example, we can find the minimum number in my array is this number 3. But what is the index of the minimum number? The index is 2. So we can also find this index. In order to find this index, we can have the argmin, let's say, function for the array x, and we assign the output into this variable and we print this variable in the output. We see that the index of the minimum value is number 2. So the index 2 is for the minimum value. We see that the minimum value in my array is number 3 and its index is 2. And here we could calculate and find the index of the minimum value, which is index 2 for the element 3. Okay, Now we would like to have the index of the maximum value. So this way argmax is going to help us to find the index of the maximum value in the X array. We assign the output into this variable and we are printing this in the output. And we see that it says that element with index 3 has the maximum value. So when we go up, we see that index 0, 1, 2, 3. So this is the index 3, and it says that the element with index 3 has the maximum value, which is true because we could see that here also we could calculate the maximum value in this array, and it was number 50 with index 3. So it now gives us the index of the maximum value. So first of all, we learned how to compute the minimum value, how to find the, let's say, the minimum value, how to find the maximum value, and we found how to find the index of the minimum value, how to find the index of the maximum value. Now let us work with a two-dimensional array here. Here is my two-dimensional array called y. We print y in the output for the reference. So it has 3 rows, row 1, row 2, and row 3, and it has 3 columns, column 1, column 2, and column 3. Okay, so we see it here in the output. And now we would like to compute the minimum value column-wise, meaning that this is the first column, this is the second column, and this is the third column. In each column, we would like to find the minimum value. In order to do that, we see that in the output for the column-wise minimum, in the first column, the minimum value among 3, 2, and 5 is 2. We see it here. 7, 9, and 8 in the second column, we see number 7 is there. And 15, 1, and 6, so 1 is there. So we see that we can find the column-wise minimum in a two-dimensional array. But how can we do that? Here we use the mean function for the array called y, and axis equals 0, meaning that we are looking for a column-wise minimum to be found. And we assign the output to this variable, which is also itself an array, and we are printing it here in the output. But what if we would like to have the minimum for the row-wise? It's the same thing. In here, we are having the minimum again, the name of the array, but here instead of the axis equals 0, meaning that it is going to do the column wise, we need to have axis equals to 1, so it is going to calculate the row wise. Now we would like to find the maximum values along the axis equals 1, meaning that the row wise. So here is my original array. We would like to have the row-wise maximum. So the first row, second row, and the third row. In the first row, which number is the maximum number? It's 15. So 15 is there. In the second row, which number is the maximum number? It's 9. So 9 is there. In the third row, which number is the maximum number? 8. So 8 is there. So we are having the row-wise maximum here in the output, and simply we call the maximum function, and we write down the name of our array. We put the axis equals to 1, so it knows that we are talking about the row-wise elements to find the maximum values in each row for us. Then we are having the index of minimum values along axis equals 0. So we are having the column wise index finding of the minimum values. Here is the output. So we see that the column wise here in this first column, second column, and the third column. So we are having 3 to 5. Which number is the minimum number? It's number 2. What is its index? Index is 1 because indexing starts from 0. Number 3 has the index 0. Number 2 has the index 1. Number 5 has index 2. So I would say number 2 is the minimum, and its index is 1. So we are having 1 here. So we are having 7, 9, and 8. Among these three elements, which one has the minimum value? So 7. What is its index? It's 0. Then we are having in the third column 15, 1, and 6. We are having it here. So number 1 is there as the minimum, and its index is 1. So 1 is here. Also, when we would like to have the row-wise indices of the maximum value. So we would like to have the index of the maximum value in each row. In this row, which number is the maximum? It's 15. What is its index? It's 2 because it's 0, this one is 1, and this one is 2. Here in this row, what is the maximum number? It's 9. What is its index? It's 1 because number 2 is the index 0, number 9 is index 1. Again, here we are having the last row, the maximum number is 8 and its index is number 1. So here we use the argmin function to find the minimum value along the x-axis 0, meaning that the column-wise, what we calculated here. Okay, so the index of the minimum value column-wise. Okay, so now in the first column, second column, third column. Argmin number of the array access equals 0. Then we are having the maximum index of the maximum values along the axis 1, meaning that the row wise, what we did here. So this is the row wise, and row wise. So this is the argmax, sorry, for the array y, and access equals 1, meaning that we are doing the row wise. So in this video, we learned about finding the minimum and maximum numbers in a one-dimensional array and how to find their indices. Also, we worked with a two-dimensional array and learned how to find the maximum and minimum numbers along the column-wise and row-wises. We learned how to find the index of minimum values when we are working with column-wise operation, and we find the maximum values when we are doing the row-wise operation. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about two main functions, reshape and ravel. So this is my array. This is my one-dimensional array. It is called X and it has these elements. For the reference, I printed in the output, so you see my array here. It's the array X. Now I would like to reshape this array into a new array that is 3 by 4 matrix. In order to do that, I can use the reshape function. So I use the X, the name of my original array, dot the reshape function, and I would say I would like to have a 3 by 4 matrix, and it is assigned to a new array that is called X reshaped, and here we are printing the reshaped. So we see that here the reshaped array extracted from the original one-dimensional array X is this one. So we are having three rows, second row and the third row, and 4 columns. So a 3 by 4. So we reshaped this array to be this array. So you see that the elements are exactly the elements of this one-dimensional array, but we only reshaped it. So we use the reshape function to convert a one-dimensional array into a two-dimensional array with 3 rows and 4 columns. Now we can have the ravel function to flatten the reshaped array. So this is my reshaped array called X underscore reshaped, and I write down the name of it, dot ravel function, and it is assigned to a new array called X raveled, sorry. And then I'm printing this out in the output. So when you see the output, you see that the reshaped array has become to the normal situation when it was as the original one. So we can use the ravel function to flatten a reshaped array. So let me say it one more time. This is the original array. We use the reshape function to convert it into a 3 by 4 matrix like this. Then we use the ravel function to convert that 3 by 4 matrix into this one-dimensional array again. Okay. Finally, I am trying to modify the raveled array. So this is the raveled array where we are having it here. However, I am changing one element of it. So I'm changing the first element, which has the index 0 of the X raveled array. So this is my original raveled array. I would like to change the first element, which has the index 0, which has the value 1. So I am assigning number 99 to it. So now I would like to have 99 instead of this. Okay, I'm assigning 99 instead of this number. So now that I did this operation, if I print the reshaped array, this matrix, if I print this one again, here we see that that modification that we did for the raveled array is impacting on the reshaped array. So let me illustrate it one more time. First of all, this is my original array. We reshaped this array into a 3 by 4 matrix. And here is the matrix. Okay. Then using the ravel function, I flattened this 3 by 4 matrix and it became something like this. Okay. Now I modified the first element of this array, which is number 1. I modified it to be 99. Okay. But although I do the modification to this array, when I reprint this matrix, here, we see that the modification is also impacting the first element of this reshaped matrix. So the conclusion is the following. When we are having a raveled array being created from a reshaped array, and when we do the modification of the raveled array for each element of the raveled array, it is going to also update the reshaped array elements. This is the conclusion of this video. So in this video, we learned how to use the reshape function and the raveled function, and we learned any modification that is done to a raveled array that is derived from the reshaped array can impact the reshaped array as well. Thank you for watching. Welcome back. In today's video, we would like to learn about transposing a matrix or a two-dimensional array. Here, first of all, we are importing the NumPy library as NP. And then here we are creating a NumPy array that is two-dimensional. It has 2 rows, so you see 2 rows and 3 columns. And the name of my two-dimensional array is matrix. For the reference, I simply first of all print my matrix in the output, so you see that this is the matrix. Now we would like to transpose this matrix. What do we mean by transpose? So you see that this is the original two-dimensional array. Transposing means that the first row will become the first column and the second row will become the second column. Okay, whenever we would like to transpose a matrix, it means that the rows will become the new columns. Now, in order to do that, we write down the name of my two-dimensional array, which is matrix dot t. Doing this will help me to transpose my matrix, and we are assigning it a new name, so transpose underscore t, and we are printing it out. And we see that here the transposed matrix is printed here in the output. So in order, the first method to do the transposing of a matrix is to use the name of the matrix dot and the keyword t. This is the first method. However, there is another method as well. So another method to do that is to use the transpose function. We can use the transpose function. So np from the NumPy library we are using, transpose function. Then in parentheses, we are having the name matrix, which is the name of my two-dimensional array. So calling the transpose function for the my two-dimensional NumPy array, which is called matrix, and it is assigned to transpose underscore function. And we are printing this transpose underscore function, and we see that Here the result is being printed out in the output, and we see that the result of transposing the matrix using the dot t and using the transpose function, they are both the same. You see, they are both the same. So the results are the same, and it is our choice to see which one we would like to choose to proceed with. So in this video, we learned how to transpose a two-dimensional array using the t method and transpose method. And if in case we were having another row, for example, here, if we were having another row, for example, 7, 8, and 9. So when I run the code one more time, we see that here we are having a two-dimensional array with 3 rows and 3 columns. The first row after transposing has become the first column, 1, 2, 3, 1, 2, 3. The second row, 4, 5, 6, has become the second column, and 7, 8, 9, the third row has become the third column. Either using the t method or the transpose function, we are getting the same result. So this is how actually we can have a two-dimensional NumPy array being transposed using the t function or the transpose function. Thank you for watching. Welcome back. In today's video, we are going to talk about stacking and concatenation. First of all, we're importing the NumPy library as np, and we are having two-dimensional arrays. This is the array 1. So it is a two-dimensional array. It has 2 rows. The first row is 1, 2, 3, and the second row is 4, 5, 6, and we are having 3 columns. First column 1, 4, second column 2, 5, third column 3, 6. This is my array 2, and it also has 2 rows, 7, 8, 9. The first row, the second row is 10, 11, and 12. The first column is 7 and 10, second column is 8, 11, third column is 9, 12. So first of all, we would like to print them here in the output. We see. Now we would like to do horizontal stacking. What do we mean by horizontal stacking? So you see that these are the 2 arrays. Now I would like to combine them to create this array. In order to create this array, we need to do the horizontal stacking. It means that the first row of the new array is containing the first row of the array 1 and the array 2. So it has 1, 2, 3 from array 1, and it has 7, 8, 9 from array 2. So the first row contains the first row of the array 1 and the first row of the array 2. Then the second row, it has the 4, 5, 6, which is the second row of the first array, 4, 5, 6, and then 10, 11, 12, 10, 11, 12. So the second row of the second array. This means that we are doing the horizontal stacking, and we are using the h stack, means horizontal stack function. In order to use the h stack, we simply call the NumPy library, and then we call the h stack function. And in parentheses, we are having array 1 and array 2. So we are having array 1 because we want to start with array 1. So 1, 2, 3, 4, 5, 6. And then array 2. Then we are going to continue with array 2, 7, 8, 9, 10, 11, and 12. We could replace them as well. So we could say array 2 and array 1. So when I run now, we see that the created horizontal stacking array is starting with 7, 8, 9, which is the array 2, and then 1, 2, 3, which is the array 1. So 10, 11, 12, which is array 2, and then 4, 5, 6, which is array 1. So this is how we can use the horizontal stacking. We can perform the horizontal stacking using the h stack. Now, if we would like to do vertical stacking, we're going to use the v stack. What do we mean by that? So we are having the array 1, once again, and array 2. Vertical stacking means that we are having a new array being generated from the columns of the first two arrays. So 1, 4, 7, 10. 1, 4, 7, 10. So the first column is the first column. The first column of the new array is the first column of the first array and the first column of the second array. So 1, 4, 7, 10, 1, 4, 7, 10. Then we are having 2, 5, 8, 11, 2, 5, 8, 11, 3, 6, 9, 12. So 3, 6, 9, 12. So this is what we call vertical stacking, and we need to use the V stack to do that. And again, we are having first array 1 and then array 2. So we are going to have the array 1 row column, for example, 1, 4, then the first column of the array 2, which is 7 and 10. This is why. And if I replace them, so here I have array 2 and here I have array 1. So if I run the code, we see that we are having 7, 10, first the first column of the second array, then 1, 4, which is the first column of the first array. So this is how it is taken care of using the V stack. And also we can do the same job like the horizontal stacking and vertical stacking using the concatenate function. In order to do the same job using the concatenate function for horizontal stacking, we can use the concatenate function. We again have the name of the arrays, but we need to have a comma here and write down axis equals 1. It means that we would like to stack column wise. We need to do column wise stacking. So when we run the code, we see that here again we are having 1, 2, 3, 1, 2, 3, first column, first row of the first array, then the first row of the second array. So let me go back and make it array 1 and array 2 because they are going to compare the result. So array 1 and array 2. So when I run here, so we are using the concatenate function. We are having the name of array 1 and array 2. We make the access to be equal to 1, meaning that we would like to have column wise stacking, meaning that here the concatenation is going to take the first row of the first array 1, 2, 3, and then the second first row of the second array, which is 7, 8, 9, then the second row of the first array, and then the second row of the second array 10, 11, 12. So when we compare this one with this one, we see that they are the same thing. So this one is done using the concatenate function. This one is done using the h stack function, but we're getting the same result. Also, we can have the concatenation for vertical stacking. So we call the concatenate function, we write down the name of the arrays, but here we need to put the axis equals 0. It means that stacking is row-wise. So here is the row-wise stacking. We are seeing that the first column, firstly, the first column of the first array, 1, 4 is written, then 7 and 10, 7 and 10, 2, 5 is written, 2, 5, and then 8, 11, 8, 11, 3 and 6 is written here, and then 9, 12, then 9, 12. So in this video, we learned how we can do the stacking using the hstack function, vstack function, or concatenate function. Here we reviewed that using the hstack function, we can do the horizontal stacking. We can use the vstack function to do the vertical stacking, and we can use the concatenate function to do the horizontal stacking and vertical stacking, but we need to be careful about the axis to be equal to 1 when we are having the horizontal stacking, and axis equals 0 when we are having the vertical stacking. Thank you for watching. Welcome back. In today's video, we are going to talk about splitting. We're going to have the use of three functions: split, hsplit, and vsplit. First of all, we are importing the NumPy library as NP. Then we are creating our two-dimensional NumPy array. So the name of my NumPy array is array. It has 2 rows, as you see here. So 2 rows, and it has 1, 2, 3, 4, 5, and 6 columns. The numbers are 1, 2, 3, 4, 5, 6. This is the first row, and this is the second row, 7, 8, 9, 10, 11, and 12. First of all, we're going to print the original array. So we see that this is the original array. Now we would like to split, for example, this array into 3 parts. The first part we would like to have 1, 2, 7, 8. This is the first part. The second part we would like to be 3, 4, 9, 10. And the third part to be 5, 6, 11, and 12. How can we do that? So we see that here in the output, we are splitting the original array into 3 parts using the split function. So here, what's happening is the following. You see that we are having 1, 2, 7, 8, 1, 2, 7, 8 as the part 1, 3, 4, 9, 10, 3, 4, 9, 10 as the part 2, and 5, 6, 11, and 12 as the part 3. We are having it in the output. So we splitted the original array into 3 parts. How can we do that? We can use the split function to do that. So I use the split function. Let me put a space here. So I use the split function. So np, because we are calling it from the NumPy library. So np dot split. Then in parentheses, we are having the array. The name of my array is array. And we would like it to be divided into 3 parts. So number 3. And we would like to have this split along columns. This is why we need to put the axis equals 1. And all of this is assigned to a split underscore array. And here, using a for loop, we are iterating through this split array, and we are simply printing out all the parts as we see here. So part 1, part 2, and part 3. So we use the split function. We write down the name of the array. We say that we want it to be into 3 parts. We want to split it into 3 parts. We put it here. And we mentioned that we would like it to be along columns, means that we are having the axis equals 1. So 1, 2, 7, 8, first part, 3, 4, 9, 10, second part, 5, 6, 11, and 12, the third part that we're having it here in the output. However, we can do the same using the H split, meaning that horizontal splitting. In order to do the horizontal splitting, we can also use the H split function. In order to do that, we use the hsplit function from the NumPy array. And in parentheses, we write down the name of the array, which is a two-dimensional array, and the name of my array is array. And we write down how many splits do we want to have. We would like to divide it into 3 parts. How many parts do we want to have? Sorry. So we would like to have 3 parts. So we write it down, and we are assigning the output to h underscore split. This is another array. Now we are writing a for loop to iterate through the h underscore split array and print different parts of it. And we see this is the output. So this is the first part, 1, 2, 5, 1, 2, 7, 8. This is the second part, 3, 4, 9, 10. And this is the third part, 5, 6, 11, and 12. So we see that this output is similar to this output. So we can either use the split function, mention the name of the array, the number of parts, and assign access to be equal to 1 to have the same result as using the h split, or we can put it to 0 to have the same result to be equal to the v.split that we're going to run in a few seconds. So far, we learned how to use the split function. We write down the name of the array, the number of how many parts do we want to have, 3. And we mentioned that we would like to have it along columns. For this, we output access equals 1. To have the same results, we can use the split function. So, but this time we don't have to write down access equals 1. We write down the array name and number 3. And that's it. This is the everything that we need to know about horizontal splitting. But if we want to do vertical splitting, in order to have the vertical splitting, we can call the vSplit function, and in parentheses we are going to have the name of the array, comma, for example, the number of the parts that we want to divide it. Because we are having now here 2 rows, we decide to divide it to 2, for example, parts are along rows. So 1 row and second row. Okay, 1 row, second row. Now the output is assigned to v underscore split, and here we are using a for loop to print v underscore split in each row. So we see that vertical splitting using v split. This is the first part, and this is the second part. The first part is exactly here, 1, 2, 3, 4, 5, 6, part 1. And the part 2 is exactly 7, 8, 9, 10, 11, 12. We see here in the output. So we see that here we can have the vertical splitting using vSplit along the rows. But if I want to do the same thing using the split function, simply we need to have the access equals to 0 instead of 1. So we write down the name of the array, which is array in this case, the number of, for example, parts that we want to have. For example, for the vertical, we want it to have 2 parts. And then we would like to have access to be equal to 0. So when I run this code, we see that we are having part 1 and part 2 that are identical to part 1 here and part 2. So now we are splitting for the vertical. It's a vertical splitting along rows. We are using the split function. And if I put it to be equal to 1 and I write down number 3 here, it is going to be splitting into 3 parts along columns. And we can do the along columns, and we can do the along rows, or let's say horizontal and vertical splitting using the split and split function. Thank you for watching. Welcome back. In today's video, we are going to talk about identifying missing values. Here, we are importing the NumPy library as NP. Then we are having this NumPy array. As you see, it's a two-dimensional array. So we are having 3 rows. The first row is here. This is the second row. This is the third row. And we are having 4 columns, 1, 2, 3, and 4. So if I make it a bit nicer, it will be something like this. So you see that here is the columns. Okay, now it's nicer. So we are having 4 columns, 1 column, second column, third column, and the fourth column. Okay. First of all, for the reference, I just print the original array. So you see the original array is being printed in the output as we are having it here, exactly here. So we are having an array, a two-dimensional NumPy array. We call it array also. So the name of the array is also array. We see that there are 3 values that are missing here. Okay, we don't have any values for them. So there are some missing values here, but how can we identify them when we are working with a large data set or when we are working with a large array? In order to find these missing values, we can use the isNone function from the NumPy library. And when we are calling this isNone, we need to put in parentheses the name of our array, which is in case array. And this is going to create a Boolean mask where true represents none values. So we are going to have this in the output. We are going to have a Boolean mask for missing values. and true means we are having none. We are having here true, we are having here true, and we are having here true. So we see that here, here, and here, they were all true. They were all missing values, and we are now having true. But why true? Because we are asking, is none exist in that element of that array? And the answer is true, because yes, there exists some missing values. And here the answers are false because there are no missing values there. Okay, so in order to first of all identify the missing values, we call the isNone function from the NumPy library for our array, which is called array, and we are assigning it to a non-mask. And this is an array with true and false values, and wherever we see true, we understand that these are the places that we are having the missing values. So this is the first step. We are identifying the basically and the missing values here. Then we would like to count the number of missing values. So for example, if you're having a very large data set, or where you're having when you're having a huge array, and you cannot, for example, count it like 1 2 3, okay, 3 missing values. If you're dealing with a large array, you cannot count it easily. Therefore, there should be a function in Python helping us to count the number of missing values. So in Python programming language, thanks to NumPy library, we can do that. So we call the count non-zero function from the NumPy library for our non-mask, okay, for our non-mask that we are having here. So for this matrix now, for this two-dimensional array, we call the count underscore non-zero function from the NumPy library for the non-mask. This one, not the original two-dimensional array, the array with true and false. And we are assigning the output to this variable, and we are printing this variable here. It is going to show the result of 3. So here the result of 3 is, it means that we are having 3 missing values. But how does it work? Why do we say non-zero? Because we in Python, in programming, usually false equals 0, true equals 1. And here this count non-zero function is going to count the number of non-zeros, and non-zeros means the number of ones, and ones means the number of truths, and we were having 3 truths here. Therefore, it is going to count the number of truths and return it here in the output. So the total number of non-values, because the truths were representing the number of missing values, if you remember. So now we are having this number 3. We understand that we are having 3 missing numbers there. Now, what if we would like to replace these missing values with a specific number? For example, we want to put 0 there. In order to do that, we are calling the none to num function from the NumPy library. We write down the name of the original array, and we separate it by a comma from the second part, which means that put the missing values or none equals 0. We're going to assign 0 to the missing values from the array, a two-dimensional NumPy array called array. The name is also array. We're calling the function none to num from the NumPy library for this array to assign the missing values to be equal to 1, and the output now is assigned to array filled. Okay, this is the new name that we choose for our two-dimensional array, and we are printing this, and we see here the missing values are equal to 0. So in this video, we first of all talked about the identifying missing values. First of all, we had the original NumPy array, that is a two-dimensional array, and there are some missing values here. So you see there are three missing values. First, we learned to use the isNone function to create a Boolean mask where true represents none. So we are having the output here. True represents missing values. True represents missing values. Okay. Then, in order to understand how many missing values do we have, we use the count underscore non-zero function to count the number of truths here, and we got to the number 3, which means that there are 3 missing values in this array. Then we decided to replace these missing values, these 3 missing values, with a specific number, say 0. So we use the none to num function from the NumPy library for our two-dimensional NumPy array called array, and assign the missing values to be equal to 0. And the output is a two-dimensional array that is called array field, and we are printing the array field. We see that the missing values are having number 0 as you see it here. Okay, so this is how we could identify and replace the missing values. And in case that you're wondering why we are putting 0, it's optional. You can put number 1 here, for example, and you see that when I run the code, the missing values are filled with number 1. Or you can put the average number that you are having in your data set to make the balance. Thank you for watching. Welcome back. In today's video, we're going to talk about replacing missing values. So here is my two-dimensional NumPy array called array, and it has these values. We are having 3 rows and we are having 4 columns, 1, 2, 3, and 4. And for the reference, I printed here in the output. So we see that 3 rows we are having. This is the first row, this is the second row, and this is the third row. And we are having 4 columns. First column, second column, third column, and fourth column. Okay. Now we would like to replace all the missing values that we are having it here. We are having 3 of them with number 0. For this, to do this, we call the none to num function from the NumPy library for the array called array, and we are assigning none equals 0. So wherever the compiler sees a missing value in the array called array, it is going to assign 0 to it using the none to num function from the NumPy library and assign the output to this part, to this variable. So this is a new two-dimensional array called array field 0. And then we are printing the array field 0. So we see that array field 0 is this array. So we see that the missing values, these 3 numbers that we were having there, are being filled with number 0. Okay, so it's very easy. We can replace them with number 1, 2, 3, etc. What a nice way here when we are working with a large data set is one solution is to ignore non-values, and instead of having the non-values, calculate the average of the elements in the array. For example, we want to ignore these 3 elements and the remaining elements that are 1, 2, 4, 5, 7, 8, 10, 11, and 12. So we calculate the mean or the average of these elements 1, 2, 4, 5, 7, 8, 10, 11, and 12. We calculate the average of these elements and we replace the missing values here with the average of the elements. But how can we do that? So it makes more sense to put the average. First of all, we need to calculate the mean of the elements while ignoring these 3 missing values. In order to do that, we are calling the non-mean function from the NumPy library for the array called array. Here it is going to compute the mean of all the elements in this array while it ignores the missing values. So the average is calculated and is assigned to mean value variable. So my average is now being stored in mean value, okay? Mean value variable. Now, in order to replace the missing values with the mean number that we just calculated, we need to call the var function. So we are calling the var function from the NumPy library, and we are having the name of my array. So we are saying that go for the array called array, and whenever you see any missing values here, we're identifying the missing values, replace them with the mean value. Okay, so var function from the NumPy library, we go for the array called array, and whenever you identify a missing value, replace it with a mean value that we just calculated, and assign the output, which is also a two-dimensional array, to this name. It is going to be assigned to array underscore field underscore mean, and then we are printing it out in the output. So here, when we are seeing the output, we see that array, after replacing missing values with mean value, we are having 1, 2, and instead of a missing value or a number 0 here, we are having 6.66. So this is the mean that we calculated for the elements, and we are replacing the missing value with this mean. So number 4, 5, again this mean, 7, 8, again this mean, 10, 11, and 12. So it makes more sense in some cases to replace the missing data or missing values with the average number of the elements. So let us review it. We worked with replacing missing values in this video. In this video, we were having a two-dimensional NumPy array that is called array, and this is the output of the original array that we are having here. Then we want to replace all the missing numbers with 0. In order to do that, we use the none to num function from the NumPy library, and we call the name of the original array, which is array, and we are replacing the missing values with 0. And it is assigned to a new array called array field 0, and this is the output. So the missing values are replaced with number 0. Now we would like to replace the missing values with the mean of array. So we need to calculate the mean of array while ignoring the missing values. So we call the non-mean function from the NumPy library for the array called array. We calculate, this function is going to calculate the mean of the array while ignoring the missing values and assign it to mean underscore value variable. Now I would like to replace all the missing values with this mean number that we calculated, with this average number. So we call the var function from the NumPy library. We go and check in the array called array whenever we see a missing value, we are going to replace it with the mean value that we just calculated, and the output finally is assigned to this array called array field mean. And when we print this, we see this here in the output. So when we compare it with the original array, we see that the missing values here and here and here are filled with the average value of the elements in this array. Thank you for watching. Welcome back. In today's video, we are going to learn about matrix operations using dot and matmul function. We are going to use these two functions in order to calculate if one matrix is multiplied by another matrix. And we are going to also use the T keyword in order to transpose a matrix. So first of all, these are two two-dimensional NumPy arrays that we are having here, or we can call them two matrix. We call them A and B. The first one is 1, 2, 3, 4. So 2 rows, 2 columns. The second one is called B, 5, 6, 7, 8. 2 rows and 2 columns. And we are first of all printing the original matrices here in the output. Now we would like to calculate the multiplication of matrix A by my matrix B. How can we do that? So this is the matrix C that we want to create from the output of A multiplied by B. In order to calculate that, for the first element, we need to multiply 1 by 5. So this is the first element of the matrix A, 1 by 5, okay, by 5, plus this number 2 multiplied by 7. Okay, this is the rule of multiplying the matrices. So 2 by 7, meaning that again 1 multiplied by 5, 2 multiplied by 7. Sorry, I wrote 5 here. So 7. Okay, this is the first element. The second element will be 1 multiplied by 6, 2 multiplied by 8. Okay, so 1 multiplied by 6 plus 2 multiplied by 8. So this is the second element. The third element would be this one, 3 multiplied by 5 and 4 multiplied by 7. So 3 multiplied by 5 plus 4 multiplied by 7. And finally, we're going to have 3 multiplied by 6 and 4 multiplied by 8. So 3 multiplied by 6 plus 4 multiplied by 8. This is the output matrix, but we need to calculate this as well. So in order to calculate it, we are having 1 multiplied by 5, so the output is 5, plus 14, so it will be 19. So this part is 19. Then we are having 1 multiplied by 6 plus 2 multiplied by 8, so the output is 22. Then here we are having 3 multiplied by 5, it is 15, plus 4 multiplied by 7, it is 43. And finally, here 3 multiplied by 6 plus 4 multiplied by 8, so it is 50. So this is the matrix of the multiplication of A and B. So we did the calculation ourselves. But there is a function here that we can calculate the multiplication. So first of all, I wanted to discuss with you how we can do the multiplication. But there is a function here in NumPy called dot, and in parentheses we mentioned that we want to multiply matrix A by matrix B, and it is going to do all the calculation itself. The output, the array output, and the output array, sorry, is assigned to dot underscore product, and we are printing the dot underscore product in the output. So this is the output array, which is exactly what we expected: 19, 22, 43, and 50. So we see it in the output. So simply we just use the dot function from the NumPy array for matrix A and B, so it is doing the calculation itself. We can also do the calculation using the matmul function. Again, we use the matmul function from the NumPy array, and for matrix A and B, the output array is assigned to this matmul underscore product, and when we print the matmul underscore product, we see this in the output, and we see that this is the same as this ones, because the output should be the same when we are not changing these two matrices. So we see that we can use the matmul function and the dot function. It's optional, it depends on us what we prefer. Then we would like to do the transposing a matrix using the T keyword. Okay, in order to do the transposing, the matrix A write it down, we write down the name dot t, and that's it. It is going to transpose the matrix and assign it to a underscore transpose, and we are printing this newly output array, and we see this is the transpose matrix of matrix A. So we are having 1, 2, 3, 4. And when we are having a transpose, it means that the first row becomes the first column of the transposed version. So 1, 2 is the first row here. Here it's the first column. So we are having 3, 4. We are having as the second row here, we are having 3, 4 as the second column here. We do the same with B, matrix B. So 5, 6, this is the first row. We are having it as the first column. 7, 8, we are having as the second row. We are having it as the second column. So in this video, we learned, first of all, how the calculation of multiplication is done between two matrices. We did the calculation ourselves manually. Then we saw that using the dot function or the matmul function, we can do the calculation very easily. Then we learned about the T to do the transposing of matrices. And we saw that the matrices A and B are being transposed here, meaning that their row become the columns in the transposed version. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about determinant and inverse. So let me illustrate the concept first, and then we're going to learn how to compute determinant and inverse of a matrix or a two-dimensional array. Here is the formula for creating a two-dimensional array, or let's say a matrix. It is called A. It has two rows, 4 and 7 is the first row. The second row is 2 and 6. The first column is 4 and 2. And the second column is 7 and 6. First of all, we want to print the matrix. So we see the matrix in the output. And then in order to compute the determinant, we need to know the formula for the determinant. The formula for determinant of a matrix A equals A multiplied by D minus B multiplied by C. But what is A? What is D? What is B? What is C? So here is my square matrix. This is A, B, C, and D. So the first element in the first row is A. The second element in the first row is B. The first element in the first row, it's A. The second element in the first row is B. The first element in the second row is C. The second element in the second row is D. So now 4 is A. 6 is D. 7 is B. And C is 2. Now, in order to compute the determinant of matrix A, we need to calculate A multiplied by D, meaning that 4 multiplied by 6, here, for example, 4 multiplied by 6 minus B multiplied by C, B multiplied by C, 7 multiplied by 2, 7 multiplied by 2. And it is going to give us the 24 minus 14. So the answer is 10. So the determinant of matrix A is number 10. This is how we can do it manually. But in NumPy, we are having a function that it does the job for us. So determinant of the matrix A can be calculated using the len alg.det. Let's say len alg.det is the name of the function that is going to calculate the determinant for us from the NumPy library for the matrix A. And the result is stored here in the det underscore A variable, and we are printing it here. So we see that the output is 10. We see it here. So this is how we can calculate the determinant manually and using a function from NumPy library. Then we would like to calculate the inverse of a matrix. But what is the inverse of a matrix? The formula for calculating the inverse of a matrix is it means that a to the power of -1. So a is the name of my matrix. When we are calculating the inverse, it means that we are calculating a to the power of -1. The formula is 1 on the value of the determinant of a, meaning that 1 divided by 10 multiplied by this. And this is where we are changing and swapping the places of our variables, of our elements in the array. So now, originally we were having A, B, C, D. Here we are having D, negative B, negative C, and A. Okay, so 1 on the divided by the number 10 multiplied by this new matrix. Okay, this new matrix is the original matrix that is swapping some of the elements. So A and D are going to swap their place. B and C are going to be negative now. And this number, 1 divided by 10, is multiplied by this matrix to calculate the inverse of a matrix. Okay. So in order to calculate the inverse of a matrix, first of all, we need to make sure that the determinant of that matrix is not equal to 0. Why? Because it's not possible to divide a number by 0, mathematically speaking. So first of all, we need to check this condition. If determinant of the matrix A is not equal to 0, then calculate the inverse using the linalg.inv from the NumPy library for the matrix A and assign the output to this name. So A underscore matrix, A underscore inverse, and then print the inverse. Okay, so it is going to print the inverse for us. So this is the inverse number. So 0.6, negative 0.7, 0.4, and negative 0.2. Basically, for the inverse here, what we are calculating is the following. So it is basically having the 1 divided by 10. Okay, so it will be something like this. 0.1 multiplied by the matrix. The value of D is 6. The value of B is 7, but we are going to have it negative 7. And then we are having the value of -2 here, and then we are having here number 4. Okay, so this is the inverse calculation. So this part, 1 divided by 10, which will be this one, 0.1, then multiplied by this newly created matrix from the original matrix. So A, B, C, D was the original, D minus B minus C and A, which is this one now. It's calculated here. So the output will be this one. It will be 0.6 because 0.1 multiplied by 6, it will be 0.6. Then 0.1 multiplied by -7, it will be negative 0.7. Then we are having the 0.1 multiplied by -2, it will be negative 0.2. And finally, 0.1 multiplied by 4, it will be 0.4. Exactly what we see here in the output. So this library, INV library from the NumPy, the INV function from the NumPy library is going to calculate the inverse of the matrix E for us very fastly. So here we check if the determinant is not equal to 0, calculate the inverse and print it. Otherwise, if the determinant equals 0, meaning that this condition is not true, go to the else part and print saying that matrix A is singular, meaning that determinant is 0 and cannot be inversed. So this is basically how we can calculate the determinant and inverse. So in this video, we learned about what is a determinant, what is an inverse, how to calculate it manually, the determinant, and how to calculate the inverse manually. And we learned how to call a function to do the calculation for determinant and also for the inverse. And we learned that if the determinant is equal to 0, it's not possible to calculate its inverse. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to solve linear equations using the NumPy library. So here we are importing the NumPy library as NP. First of all, we are defining the system of equations that we are having. So this is the system that we want to solve. There are two equations, 2x plus 3y equals 8 and 5x plus 7y equals 19. So this is the system that we would like to solve, and we need to find the values for x and y in the end. In order to solve this, first of all, we need to have a matrix representing the coefficient like 2, 3, 5, and 7. So we are creating a matrix using the NumPy library. Let's say we are creating a two-dimensional NumPy array called A, and we are having 2, 3, 5, 7. So 2, 3, 5, 7. And we are creating, let's say, another matrix, or let's say a vector or array here for the constant. So 8 and 19. So 8 and 19. And we call it B. So one array for the coefficients and one array for the constant. First of all, let us print these two. So this is the coefficient matrix, and this is the constant vector, 8 and 19. Now we would like to solve this equation. In order to solve it ourselves manually, it would take quite some time. So we need to first multiply this equation with the constant to be able to remove the y and then or remove the x and then do the calculation. For example, here, if I want, I can multiply the first one with number 7, for example. So it will be 14x plus 21y equals 56, and also multiply the second equation by minus 3. So it will be negative 15x plus negative 21y equals, so it will be 19 multiplied by minus 3. So I need to do the calculation for this one. The 19 multiplied by minus 3, it will be negative 57. So now if we add these two equations, we can remove this one with this one. So the next step will be this. We are going to have negative x equals negative 1. Therefore, x equals 1. Okay. So this is what we can get from the x, for the x here. Then we need to put the value of x in the equation to calculate the value of y. For example, here in this equation, if I put x, so x equals 1, so we are going to have 14 multiplied by 1 plus 21y equals 56. Okay, so we do the calculation, it will be 21y equals 56 minus 14. Yes, so the output will be 21y equals 42. Therefore, y equals 42 divided by 21. Therefore, y equals 2. So y equals 2 and x equals 1. This is the output of this system. So we have these two equations here, and we would like to find the value for x and y. First of all, we need to change these two equations in a way that we can remove one of the variables. For example, we can remove y or we can remove x. So that it will become one variable and then the constant, so we can calculate the value of that one variable, and then we put the value for that one variable in the original equation and then calculate the other variable. So this is what we did. So this is in order to remove the y variable. We could remove the x variable, but it is our choice. So in order to remove the y variable, I multiplied this equation by 7. So 2 multiplied by 7 is 14x. 3 multiplied by 7 it's 21y. 8 multiplied by 7 is 56. Then we multiplied this by minus 3, so that the y will be the coefficient of y will be minus -1. So this minus -1 added to this one, they will be 0. Then we are having 14x negative 15x. So the output will be minus x when we are adding them. And when we add these two constant, it will be -1. Negative with negative, they make each other to go. So we are going to have x equals 1. Now that we are having the x equals 1, we put the x either in this equation or in this equation. It's the same. So I put it in the first equation, 14 multiplied by 1 plus 21y equals 56. After doing the calculation, we calculate the y equals 2. But there is another way to calculate this. It's much easier. How? We call the solve library using the solve function from the NumPy library, and we pass these two matrix that we created. This is the first matrix of the coefficient. This is the matrix of the constant. Okay, so we call the solve function from the NumPy library, and we pass these two matrix and we assign the output to a variable called solution. And when we print the solution, we see that the solution for x and y, it's 1 and 2, exactly as what we got. X equals 1, y equals 2. So here is the solution. But there is a way to also verify our solution. In order to verify the solution, we need to calculate the multiplication of the A matrix with this one by this solution to get this number. So if I multiply the original matrix, the coefficient matrix, if I multiply the coefficient matrix by the solution, and if the output of this multiplication is the constant vector, which is 8 and 19, it means that the solution is verified and we got the correct solution. So if we multiply this by this and the output we get this, it means that the solution is correct. Therefore, we multiply A by the solution found, which is 1 and 2 for x. So this matrix is multiplied by this matrix, and the output is printed here. So the output is computed B that we are calculating ourselves. So it is 8 and 19. And the original B, when we print it here, this is 8 and 19. So it means that we are checking to see if they are equal or not. So in order to check if the solution is correct or not, we can say all close. So this is the function, meaning that check to see if they are almost the same or they are equal completely. So we call this function from the NumPy library to check if the solution that is stored in the AX equals the numbers in B, and it returns the value true, meaning that the solution is verified. So in this video, we learned how to solve linear equations using the solve function from the NumPy library. We had these two equations. We learned how to solve them and find the value for x and y manually. And then we learned that we can call the solve function to do the job for us. And we learned how to validate the output to make sure that we are having the correct solution. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about copy and view function. This is copy function, this is the view function. So first of all, we're going to import the NumPy library as NP. This is my NumPy array. So we are creating a NumPy array with 5 elements, 1, 2, 3, 4, 5, and the name of this array is array. So first of all, I'm going to print the original array. So we see that the original array is being printed in the output 1, 2, 3, 4, 5. So this message is first shown, original array, and the array is being printed using the print function. Now we would like to create a shallow copy of our original array. So a shallow copy, when we would like to do that, we write down the name of the array, dot, we call the view function. When we call the view function, it is going to create a copy of the original array that shares memory with the original array. Okay, and the view, the shallow copy is assigned with the name of array underscore view. Then we would like to start modifying the copied array, the shallowed copied array, first element. So we would like to change the first element of the array view and assign it to be 100. Now it is 1. So let me put it here. So when we are having the array view equals, for the moment it is 1, 2, 3, 4, 5. Using this line, we are assigning number 100 to the first element that has the index 0 of the array view array. So after doing this line, after executing this line, the first element will become like this. Okay. Now we modified the shallowed copy version of the array, not the original array. However, when we print again the original array and the copied version, we see that here also the original version of the array has been modified. And also the view of the array is this. So when we are using the view function to shallow copy an array, and after that we modify the copied version, it is going to not only impact itself, but also to impact the original array because they share memory. This is the lesson of this. So after the modification of the view array, we see that the first element in the original array has been changed. And also we see that the view array also has been changed because we modified the first element with index 0 of the view array. So this is the first way to copy, or let's say view an array. So we learned about the view function. Now let us work with the copy function. Now I would like to create a copy of the array, of the original array, which is named also array. So I write down the name of the array, which is array.copy. So the copy function is going to create a true independent copy of the original array, and we assign it to array underscore copy. Now we start modifying the copied array. So I'm putting the number 200 as the second element with index 1 of array underscore copy. And now I print the original array plus the copied array. So when I print the original array, we see that the original array is now 100, 2, 3, 4, 5. It's exactly like this. So they are similar and there is no modification made here. But when I print the copied array, we see that it starts with 100, but the second element is 200 and then 3, 4, and 5. So the modification that we did here for the copied array has impacted the copied array, of course, but has not impacted the original array. Therefore, when we are using the copy function, it means that we are creating a true independent copy of the original array, meaning that any modification that is done to the copied array is not going to impact the original array. However, when we are using the view function and we create a view of the array, whatever we do and modify for the view array is going to directly impact the original array. Why? Because they share memory. So here was how we could work with the view and copy function. And now we would like to check the memory addresses of these three arrays. So the original array, view array, and the copy array. So when we print the original array address, we use the name of the array, then this keyword in order to access the memory address of the original array, of the view array, and of the copied array. And when we check the output, we see that the original array address is this number. So 230.55.82.4, and the view address, the view array address is exactly the same number. You see, because they share memory. Okay, so the original array and the view address, view array is going to have the same memory address. However, for the copy array, we see that the memory address is different because we are creating an independent copy of the original array. Okay, so to summarize, here is the table that I provided here. For example, for the view function and the copy function, share memory with the original one. With the view function, if we create a view array, yes, it is going to share memory with the original array. But when we are having the copy array, no, it's not going to have a shared memory because it is totally independent. Is it going to affect the original array if we modify anything in the view array? Yes, it is going to impact the original array when we modify its element. But when we are using a copied array, it is not going to impact the original array when we do any modification. With respect to the view array, is it faster? Yes. But in the copy array, is it faster? No, because it needs to create a new memory. But this one is sharing the memory, so it's faster. And for the view array, is it independent? No, it's not independent. It is dependent on the original array. But with respect to the copy array, is it independent? Yes, it's a totally true independent copy of the original array. So in this video, we learned about the copy function and the view function, how to work with them, how to create a view array, how to create a copy array, and we also learned the differences between them. Thank you for watching. Welcome back. In today's video, we're going to talk about structured arrays. So we are going to import NumPy library as NP. And first of all, we would like to define a structured data type. In order to define that, we would like to have a structured array with three fields: name, age, and weight. I would like the name to be a string, the age to be integer, and the weight to be a float. And this is, we gave the name of dtype to this structured array. Now I would like to create my structured array. Okay, so here was the definition of a structured data type. So this is my structured data type, and this is my structured array. So I would like to create a NumPy array called people, and each element of this NumPy array needs to have exactly this in the same format. So you see here, we're having the first element having the name, age, the name, age, and the weight. So name, age, and the weight. Okay, and the format of the name is a string. You see, the age is integer and the weight is a float. So we are creating a structured array based on our structured data type dtype. The first element is, for example, Alice, that has 25 years old and with the weight of 55.5. The second element is Bob with age of 30 and with the weight of 75.2. And finally, the third element is Charlie with the age 22 and the weight of 68.4. And we are creating a structured array called people from the structured data type D type. Okay, so this is how we define first of all the structured data type and how we create the structured array. Now first of all, let us print the structured array. So we print here the structured array. We are having the first element, the second element, the third element, and we see that each element is having all the information that we defined in our structured data type. So the name, age, and weight. So name, age, and weight. Now, we would like to learn how to access specific field. Before that, let me put it here because this is the first element, the index is 0. This is the second element, the index is 1. And this is the third element here, the Charlie, and therefore the index is 2. So we know that we are going to start indexing from 0. So we are having the index 0, index 1, and index 2. So now, how can we access specific fields? Each part is field. So this is one field, this is another field, this is another field. How to access specific field? For example, here I would like to have the access to the people array to the field of name. Okay, so this is the field. So when we are calling the first element is having 3 information. The second element, 3 information. The third element, 3 information. But when we call the field, this is the definition of the field. So when I would like to access all the names, I would like to access the name field, I would say. Okay. So this is the first element, not the first field. Sorry. So when I would like to access the all the field of the name, so name field, it means that I would like to have access to Alice, Bob, and Charlie. Or if I say that I would like to access the age field, means that I would like to access 25, 30, and 22. So now I would like to access a specific field. First, this message is shown. Then, in order to access the, for example, name field, I would write down the name of my structured array. Then in square brackets, I simply write down the name of the field. And now the name of the field that I would like to access is name. Here, the name I would like to access the age field, so I write down the name of the structured array, which is people, and in square brackets, I write down the name of the field, which is age. So when I print them, we see here the accessing specific fields. In the names, we are having Alice, Bob, and Charlie. So all the names are being printed here in the output. Alice, Bob, and Charlie. Then with respect to ages, we are having 25, 30, and 22. So in order to access a specific field, we can write down the name of the structured array, then the name of the field itself, and we can access to it. Now, how we can filter based on conditions. If I want to filter based on conditions, for example, I would like to get people that are younger than 30 in the output. In order to do that, we write down first of all the name of our structured array, which is people. Then we would like to access the specific field, which is age, because we are looking for people that are younger than 30. So then from the people structured array, we want the field age that are lower than 30. Okay. So first of all, the name of the array, the structured array, then exactly like accessing the field. So we were using this line, this part to access a specific field. So I would like to access the age field. So I write down people in a square bracket age. So I write it down, and I would like to have the people that are younger than 30, so lower than 30. Okay, and this is assigned to young underscore people. And when I print that, we see that for younger people than 30, we are having the Alice 25 with 55.5 weight, and we are having Charlie. So the information of the elements that are having the age that is lower than 30 is being printed in the output. How? We can filter them. In order to filter them, we write down the name of the array, then the name of the array, and in a square bracket the name of the field that we are looking for. And this is the condition because we are looking for younger than 30, and this is assigned to a new structured array, let's say young people, and young people is being printed. We see that we are having Alice and we are having Charlie in the output. Now let us discuss the modification. So how can I modify values in a structured array? If I want to change Bob's weight, so this is Bob and it's the weight of him is 75.2. Now I would like to change it to 80. So I write down the number 80, and I remember that Bob is the second element with index 1. So I write down the name of the array, the name of the field that I would like to modify, and the name of the index, which is 1, and I assign it to be 80. Now that it's 80, it is going to change the Bob's weight from 75.2 to 80, or let's say we are assigning number 80 to the index 1 of the weight field from the people structured array. So index 1 of the weight field from the people array. We are assigning 80 to it. So now if I print the full structured array here, we see that Alice is there, Charlie is there, Bob is there, but his weight is now 80 and it is modified. We can do it, for example, for another person. For example, we can do it for Charlie as well. So if I want to modify the weight of Charlie, simply I know that Charlie has the index 2. So I write down number 2 here. And instead of 80, I would say, for example, 60. So now I'm assigning number 60 to the index 2, which is the Charlie, to the field weight field, which is 68.4 of the people structured array. So we see that here now we are modifying the weight of Charlie. So when I run the code, we see that now Bob is 75.2, exactly like the original one, but the Charlie's weight is now 60, which was originally 68.4. So depending on what we are looking for, we can modify that code, and we can define another, for example, structured array as we want. So in this video, we learned about defining a structured data type, first of all, and creating a structured array. We learned how to access specific fields using the name of the fields, and we learned how to filter based on a certain condition, and we learned how to modify values. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about the memory layout. So we are going to specifically talk about C contiguous and F contiguous. So we are defining C contiguous and F contiguous about how multi-dimensional arrays are stored in memory. For example, for the C contiguous configuration, we call it also row major order. They store data row by row in the memory, and they are default in NumPy library. So it's the default in the NumPy library. So when we are having a multi-dimensional array, it is by default C contiguous. So it's a row major order. And basically, they are faster for row-wise operations. However, we are having F contiguous that are column major order, and they store data column by column in the memory rather than row by row. Okay, column by column. And they are used in Fortran and Matplotlib, and they are faster for column-wise operation. Well, let us provide a comparison. So for the C contiguous, the memory layout is row-wise, so left to right. But for the F contiguous, it's column-wise, top to bottom. Okay. Then For the C contiguous, it's the default in the NumPy, but F contiguous is not the default by NumPy. C contiguous, they are best for row-wise operations and they are faster for iterating over rows. However, the F contiguous, or let's say the F order, or we call it, they are best for column-wise operations and they are faster for iterating over columns. So whenever we are working with columns, it's better to use the F order or F contiguous, but whenever we are working with rows operations or we are iterating over rows, it's better to use C contiguous or C order. So let me illustrate all of this with an example. Now we are having a NumPy array, which is called a C array, and this is two-dimensional. So this is the first row, this is the second row, and it is a C contiguous array. Okay, in order to make sure, although by default it's the C contiguous, but I wanted to emphasize on this. So I'm having the order equals C, meaning that it's a C contiguous array. So I created a C contiguous NumPy array with 2 rows and 3 columns here. Now I would like to print it here in the output. So I print it here in the output. So I would like to check with the compiler to see if this one is the contiguous, C contiguous or not. So the C array, I would like to make sure if it's a C contiguous or F contiguous. In order to check that, we write down the name of our array and then dot flag. The flags is there. Then in square brackets, we are having the C contiguous and F contiguous. For the first one, we expect to see the result true because we mentioned that we are having a C contiguous array. For the second one, however, we expect to see the result false because this is not a F contiguous NumPy array. So when we run the code, we see that is it C contiguous? Yes. Is it F contiguous? The result is false. So in order to check if it's a C contiguous or F contiguous, we write down the name of the array, dot flags, and in square brackets, we write down C contiguous to check if it's C contiguous. And if we wanted to check to see if it's F contiguous, we write down F contiguous. Now, let us create an F contiguous array. So we call it F array, and it is again a two-dimensional array with 2 rows and 3 columns, and the order equals F. It means that it's a F contiguous array, and here is the creation of our F contiguous array named F array. So we print the F array. So we print it here. This is the F contiguous array. So we see that in appearance, there is no difference, okay, with the C contiguous array. There is no difference in the appearance. The difference is in the memory layout. So we cannot see it here in the output. They are both arrays with the same numbers and same elements. Now that I created the F array, I would like to again check if the F contiguous, if this array, F array, is F contiguous or C contiguous. So I write down the name of the array, dot flags. Then in square brackets, I check C contiguous, or here I check the F contiguous. For the C contiguous, we expect to see the result of false because it's the F order. And for the F contiguous, we expect to see the result true. So when I run, we see that is it C contiguous? False. Is it F contiguous? True. So this is true. Now, what if I want to convert between memory layouts? So first, if we want to convert from C to F, we can have from the NumPy library, we call this function, and simply we write down the C array. So the C array is C contiguous, and I would like to convert it to F contiguous. Let's say F order. So I write down the name of the function from the NumPy library, and in parentheses, I write down the C array. C array is there, so we assign the output to C to F, and when I print the C to F, here what we are going to see, C to F. 1, 2, 3, 4, 5, 6. So this is the converted C order to F order array. And we check, is it F contiguous? Yes, the answer is true. So here I check to see if C to F flags F contiguous. The answer is true, meaning that we successfully converted the C order to F order. Now we are having the conversion from F order to C order. In order to do that, I call this library from the NumPy, I call this function, sorry, from the NumPy library. And in parentheses, I write down the name of my F order array, which is called F array. So I would like to convert, this is originally an F order. I would like to convert it to C order. So this function from NumPy library, and in parentheses, we are having the F array. And we are assigning it to F to C. And when I print F to C, we see this is my array. So you see that they are both identical. But the difference is in the memory layout. And we check this condition again. Is it C contiguous F to C? Flags C contiguous, the answer should be true. And the answer is indeed true, meaning that we successfully converted them. So first of all, in this video, we learned about C contiguous and F contiguous that are defined for multi-dimensional arrays and the way that they are stored in the memory. For the C contiguous, they are, or let's say row major order, they are stored row by row. They are by default and they are faster for row-wise operations. However, the F contiguous, or let's say column major order, they are stored column by column in the memory and they are faster for column-wise operations. And we did make a comparison here as well. So whenever we are working with the row operations, it's better to have a C contiguous array. And whenever we are working with the columns operations, it's better to have the F contiguous array. It's faster and it's best for, they are designed specifically for this job. So, and then we learned how to create a C contiguous array. So it's by default C contiguous, but we also wanted to emphasize, so we write down here. So an array called C underscore array. These are the elements, and in order to make sure that it's a C contiguous, we have the order equals C. We check, in order to check to see if it's C contiguous, we write down the name of the array dot flags, and in square brackets, we are having the C underscore contiguous to check if it's C contiguous or not. If the answer is true, it means that it's a C order. Then we created an F contiguous using the order equals F. We check to see if it's F contiguous or not. Then we learned how to convert a C order to F order and an F order to C order. And finally, we print them out in the output. Thank you for watching. Welcome back. In today's video, we would like to create a one-dimensional array with values ranging from 0 to 9. In order to do that, first of all, we're importing the NumPy library. Then we are having the array called ARR. So this is my array name. I can say array1 for just for clarity. We can say array1. So this is the array1 is the name of my array, and I would like it to range from 0 to 9. So I can use the arrange function to range from 0 to 9. Basically, it is going to start from 0 and it is going to go up to 9 inclusive, and it is not going to include number 10. This is why we go up until number 10. So the ending point is not included. Therefore, the arrange function is going to help us to start from 0 and go from 0 to 9. And then in the next step, we are printing this array1. So when I run the code, we see exactly here. So if I want to create another one, for example, array2, we can have array2, and we can have, for example, the array function from the NumPy library to have it from 0 to 9 as well. So I call it array2 and I print the array2. So when I run the code, we see the exact same output. So we would like to create a one-dimensional array values with values ranging from 0 to 9. We can either use the arrange function and type the ending point exclusive. So it is going to be number 10. So it is going to print us from 0 to 9. Or we can have the second array that is going to start from 0 and it is going to go on up until 9 using the array function from the NumPy library. And if I want to, for example, have array 3, I could have, for example, this array, and this array 3 is going to help us to have an array with values ranging from 0 to 9, but this time I use the array function. Okay, instead of writing down all the numbers myself here, I'm going to use the range function and I'm going to have range up until 10. So when I run the code and print the third array, we see the exact same result in the output. So there are many ways for us to understand, for example, how we can create a one-dimensional array and how we can create our one-dimensional array ranging from one number to another. But here we learned three basic methods here to do that. And if I want to, for example, have an array going up to 100, we can have the array 4 and we call the arrange function and we can write down 100 here. And in the next line, I'm going to print the array 4. So when I run this code, you see that it starts from 0 and it is going to go up until 99. So in this video, we learned how to create a one-dimensional array with values ranging from 0 to 9. We can use the arrange function. We can use the array function and write down all the numbers ourselves, or we can use the array function and then call the range function to do the work for us, so we don't have to write all the numbers ourselves. And if in case we want to change the ranging values, we can go ahead and do it. And here, for example, I am having array 4 ranging from 0 up until 99 included. So here is the output. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to convert a one-dimensional array to a two-dimensional array with 2 rows. So when I run this code, we see that we are having a one-dimensional array. So first of all, I am importing the NumPy library here, as you see. And here I'm having the array called R. I would say array 1, let's say. And this array 1 is being created using the arrange function, and for numbers between 0 and 9. And 10 is not included, therefore it's going to be from 0 to 9. And then we are printing the array 1, so we are printing the array 1 here. We see that it's a one-dimensional array. But how can we make it a two-dimensional array? How can we convert it? In order to convert, we can have the reshape function, and this reshape function is going to tell the compiler, okay, this is the one-dimensional array with this range, this is name, this is the name of the array, etc. But I would like it to have it as a two-dimensional array with 2 rows, okay? And this number, -1, tells the NumPy automatically determine the number of columns based on the given number of rows. So this is the number 2. This is why it's there. So when I run this code now, you see that we are having 2 rows. The first row is 0, 1, 2, 3, 4. The second row is 5 to 9. So using the reshape function, we can convert our one-dimensional array with values between 0 and 9 to a two-dimensional array. But if I want to have like more than 2 rows, is it possible? In some cases, yes. But for example, here we are having numbers that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 8 and 9. Okay, so we are having 10 numbers here. Is it possible to, when 10 is divided by 2, so when 10 is divided by 2, the remainder is what number? What is the remainder of this division? Using the modulo operator, we can find the remainder of this division. 10 divided by 2, the remainder is 0. Why? because 10 is divisible by 2. Therefore, when we are having 10 elements, it is possible to have 2 rows. Okay, because 10 is divisible by 2. Because when 10 is divided by 2, we have the remainder equals 0. However, if we are having 10 numbers in my array and I would like to have 3 rows, for example, I would like to have 3 rows. What is the remainder of this division? This is not 0. For sure, it's not 0 because 10 is not divisible by 3. Okay, so this is not equal to 0. Because it is not equal to 0, therefore, it's not possible to have a two-dimensional array with 10 numbers that to have 3 rows. Because if you want to have 3 rows, you should have, for example, 0, 1, and 2 for the first row, 3, 4, and 5 for the second row, and 6 and 7 and 8 for the third row. And what happens to the last number? Okay, the fourth row is there because we are having number 9 there, but we wanted 3 rows. So if we want 3 rows, maybe we should put more numbers in each row. So if I put number 3 here, so I put 6 and 7 here, I put 8 and 9 here. So what happens now again? Again, we are not having enough numbers to fill the matrix or the two-dimensional array. Therefore, it's not possible to have a two-dimensional array with 10 values with 3 rows. You see, this is the reason why. Therefore, we cannot ask the compiler to give us an array with numbers from 0 to 9 with 3 rows. If I run, there will be an error. So you see there is an error because we don't have enough enough space to put them. It says cannot reshape array of size 10 into the 3 rows. So what if I want to have like for 5? It's possible. Why? Because when 10 is divided by 2, 10 is divided by 5, 10 divided by 5, the remainder of this division is 0. Okay, when the remainder of this division equals 0, it means that it's possible. Therefore, we are having 5 rows here, as you see, for our values. So in this video, we learned how we can convert a one-dimensional array into two-dimensional array using the reshape function. And we saw that we need to be careful about choosing the number of rows. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have the multiplication of two metrics. So first of all, we're importing the NumPy library and as MP, and then we're going to create our two matrices. So matrix 1, we are using the NP, meaning that we're using the NumPy library, and we are generating random numbers for creating a 5 by 3 matrix. So these are the dimensions with 5 rows and 3 columns. And all the numbers that are being generated are between 0 and 1. So the matrix 1 is going to have 5 rows and 3 columns. Then we are having matrix 2, where we are randomly generating numbers to create a matrix with 3 rows and 2 columns. So we're going to make the multiplication of this one with this one. But first of all, let us print these two arrays. So the first array that is being randomly generated is this array. You see we are having array 1, array 2, array 3, array 4, array 5, and then we are having 3 columns here. Then we are having the second matrix, which is here. So it has 3 rows, as you see, because we expected to have 3 rows and 2 columns and 2 columns, you see. So 3 rows and 2 columns, okay? Now we would like to do the multiplication. In order to do the multiplication, we can simply use the dot function from the NumPy library, and in parentheses we write down the name of our matrices. So mat1 and mat2, and the output of the multiplication of these two matrices is going to be assigned, the output is going to be assigned to a matrix called a result. And here we are printing the result matrix, and we see we are having the result matrix here. For example, we see here we are having 5 rows and now 2 columns here, because we were having a 5 by 3 matrix being multiplied by 3 by 2 matrix. So the resulting matrix will have 5 rows and 2 columns. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to learn how to extract all odd numbers from an array of 1 to 10. So first of all, we need to create this array. In order to create that, we are having the name of array, which is array1, and we are using the arrange function to extract all odd numbers between 1 and 10. Okay, so the starting point is inclusive, so 1 is there. But since the ending point is not inclusive, we are writing 11, but it is going to go up until 10. And in order to extract the odd numbers, how can we identify the odd numbers? If an odd number is divided by 2 and the remainder of this division is not equal to 0, it means that that number is odd number. So we are having for array 1, each of the elements that is inside the array 1 that is divided by 2 and the remainder of that division is not equal to 0 is assigned to odd numbers, and we are printing odd numbers here. Okay, so for all the elements that are in array 1 and if they are divided by 2, the remainder of this division is not equal to 0, it's an odd number. For example, here, let me first print the array 1. So this is the array 1. So 1 is divided by 2, the remainder of this division. Is it equal to 0? No, it's not. Therefore, 1 is an odd number, and we are adding 1 to the odd numbers array. So we are having it here. Number 2, is it divided, when it is divided by 2, the remainder of this division, isn't it equal to 0? No, it is equal to 0. In fact, it is equal. Therefore, we are not going to add it into the odd numbers. What about number 3? 3, when it is divided by 2, the remainder of this division is not equal to 0. Is it true? Yes, it's not equal to 0. Then we are going to assign that number to odd numbers, and we see that 3 is there. We are going to continue up until the end like this. So then we're having number 4. We check to see if number 4 is divided by 2, the remainder of this division is not equal to 0. Is this statement true? No, it's not true. Therefore, 4 is not added here. Then next number 5, it's divided by 2, the remainder of this division is not equal to 0. Is it true? Yes, it's true. 5, when it is divided by 2, the remainder is not equal to 0. Therefore, this statement is true. And then because this statement is true, we're going to assign it to the odd numbers. And 5 is there. Then we check with number 6. 6 divided by 2, the remainder is 0, so this part is not true. 7 divided by 2, the remainder of this division is not equal to 0, so this statement is true. We are adding it to the odd numbers. We see it here. For number 8 and number 10, again, this statement is not true, so it is not going to be added to the odd numbers. But for number 9, it's true, because 9 divided by 2, the remainder of this division, is not equal to 0. Yes, this statement is true. Therefore, we are adding it to the odd numbers, and we see that here number 9 is also there. And here we use the print function to print all the numbers that are in odd numbers. So now in this video, we learned how we can extract all the odd numbers. But what if we want to extract all even numbers from an array of 1 to 10? In order to do that, for example, I write down even numbers. and this is the name of my array, and I say for all the elements that are in array 1, if that element is divided by 2 and the remainder of this division equals 0, it means that that number is even. So if this statement is true, assign that number to even numbers array and print it here. So here you see that we start from the original array. So 1 divided by 2, the remainder is equal to 0? No. Therefore, we're not going to do anything. So this statement is not true. Next iteration, 2 divided by 2, the remainder equals 0. Is it true? Yes. So add 2 to the even numbers. We print the even numbers, so 2 is here. 3 divided by 2, and the remainder equals 0. No, therefore it's not an odd number because this statement is not true. We are not going to assign anything to even numbers array. Number 4, the next number, divided by 2, the remainder of this division equals 0. Yes. So it equals 0. We are going to assign it to even numbers and we print the even numbers. So 4 is there. 5 divided by 2, the remainder of this division equals 0. No, it's not. So the remainder of this division is not equal to 0. Therefore, we are not adding it to even numbers. Then we are having the number 6 divided by 2. Is it equal to 0? Yes, because 6 divided by 2, the remainder is 0. The output of this division is 3, but the remainder is 0. Therefore, we are going to assign that number to even numbers. Then for number 7 and 9, the same thing happens. If they are divided by 2, the remainder is not equal to 0. So this statement is not true. We are not going to add them to the even numbers. But for number 8 and 9, if they are divided by 2, the remainder of their division equals 0. So this statement is true. Now that this statement is true, we are going to add them to even numbers array, and we print the even numbers array here. So the even numbers array, the even number arrays is here 2, 4, 6, 8, and 10. But for the odd numbers, we were having 1, 3, 5, 7, 9. And we can play with the range. For example, here we are having the range between 1 and 10. We can say the range between 1 and 100. 1 and 100. So when I run, we see that here is the original array. All the numbers between 1 and 100 is being printed. Then all the odd numbers between 1 and 100 is being printed here as the odd numbers, and all the even numbers is being also printed here. So in this video, we learned how to extract odd and even numbers from an array. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to replace all odd numbers in an array of 1 to 10 with -1. So first of all, we need to create our array. This is my array. You see, array 1 is the name. We are having the arrange function to create it for numbers between 1 and we're going to have up until number 9 because the end is not included. So if I want to go up until 10 included, I should write 11 here, okay? So the thing is that we would like to have the output something like this. So all the odd numbers to be replaced by number -1. And for even numbers, it's okay. We are going to have them as you see here, okay? So how can we do that? So we created the array here. Then for all the elements in the array 1, if that element is divided by 2 and the remainder of this division is not equal to 0, it means that that number is an odd number. So assign number -1 or -1 to that element. What do we mean by that is the following. So for all the elements that are in array 1, so for example, for the first element that is 1, first let me print the array 1. So this is the original array, and it starts with number 1. So number 1, if it's divided by 2, the remainder of this division is not equal to 0. Yes, this statement is true. Therefore, number 1 is an odd number. Therefore, we are going to replace it with number -1. So in the new array, we see that -1 is there. Then for the next number, 2 is divided by 2. The remainder of this division is not equal to 0. This statement is not true, okay? Because when 2 is divided by 2, the remainder of this division equals 0. So this statement is not true. Therefore, we are not going to assign -1 to instead of number 2. So number 2 is there itself. Then number 3. So number 3 divided by 2, the remainder of this division is not equal to 0. Is it true? Yes. If it's true now, assign -1. So -1 is assigned there. Then we are going to have number 4. For number 4, 6, 8, and 10, which are even numbers. If they are divided by 2, the remainder of this division is not equal to 0. So this statement is not true for these numbers. Therefore, we are not going to assign -1. So 4 is 4, 6 in the original array is like remaining 6, 8 is 8, and 10 is 10. Then we are having the other numbers that are odd. For example, 5, 7, and 9. So when these numbers are being divided by 2, the remainder of their division is not equal to 0. Is it true? Yes, it's true. Therefore, assign -1. So -1 is instead of number 5, -1 is instead of number 7, -1 is instead of 9 in the output as we see. If we want to do the same with even numbers, for example, here we did the replacement of odd numbers. So instead of all the odd numbers, we assigned -1. Okay. But if we want to do the same thing with odd numbers, simply we can remove this one and assign, sorry, we need to have this equal here. So when we are having 2 equals, it means that, for example, that element, if it's divided by 2, the remainder of this division equals 0. Yes, then assign -1. So here we are assigning -1 instead of even numbers, as you see. Because if a number is divided by 2 and the remainder of this division equals 0, it means that that number is even. So in this video, we learned how we can, first of all, create an array within a range. Then we learned how we can replace odd numbers or even numbers of that array with another number. For example, with -1. We can have the -10, for example. Instead of all the even numbers, assign a -10. So -10 is there. You see, -10 is there. So this is how we can replace numbers in an array. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to learn how to convert a one-dimensional array to a Boolean array where all positive values become true. So first of all, this is the importing of the NumPy array as NP. Then we are creating our array called ARR. In order to create a NumPy array, we use the NumPy library and the array function. And then these are the elements of my array: -1, 2, 0, -4, and 5. So we would like to convert this one-dimensional array to a Boolean array where all positive values become true. So all the positive values that we are having, 2 and 5, we would like them to become true. In order to do that, first of all, let's see the output. So we see that we converted it to a Boolean array, and we see that we're having false because a -1 is not a positive number. Then we're having number 2, which is true now. We're having 0, which is false. We're having -4, which is false, and we're having 5, which is true. So all positive values become true. In order to do that, after creating our array, we need to set a condition, and the condition is the new array, that is a Boolean array, is called Boolean underscore ARR equals all the elements that are in our original array ARR that are larger than 0. So if the element of the original array called ARR is larger than 0, it is, and this statement is true, we are going to assign true in the elements, otherwise we're going to assign false. So let me illustrate it with the example. So the first element of the original array is -1. It checks to see if -1 is larger than 0. Is this statement true? No, this statement is not true. Therefore, we are going to put false because we are checking this statement, and this statement is false. Therefore, false is assigned to boolean underscore ARR. So to our boolean array is having the false as the first element. Then we check to see number 2. 2, is it larger than 0? This statement, is it true? Yes, this statement is true. Therefore, true is assigned to the boolean array. Then we go for the next one. We are having 0. Is it larger than 0? No, 0 is not larger than 0. So this statement is false again. So false is assigned to our boolean array. Then we are having -4. Is it larger than 0? -4, is it larger than 0? No, this statement is false. Therefore, false is assigned to our boolean array. And finally, we are having the last element, which is 5. Is it larger than 0? Yes, this is larger than 0. So this statement is true. Therefore, true is assigned to our boolean array. So far, we learned how we can convert a one-dimensional array to a boolean array where all positive values become true. But we can check other conditions as well. So I have, for example, array2 equals, first I call the NumPy library and then the array function. And inside the array function, I'm going to put my numbers. For example, 1, 5, 8, 12, 20, 50, 7. Okay, this is my second array. Then I would like to create my next boolean array. So boolean array2 equals, if array2 is larger than 10, we're going to print it. So I created a new array, a new one-dimensional array, and the elements are 1, 5, 8, 12, 20, 50, and 7. Now I would like to create a new boolean array, and for each element of the array2 that is larger than 10, we're going to assign true, otherwise we're going to assign false. So I run the code one more time, and we see here, for example, the first element of the array2 is number 1. Number 1, is it larger than 10? No, therefore this statement is false. We see false here in the output. Then we are having number 5. Is it larger than 10? No, it's not. Therefore, this statement is wrong and it's false. So we put false in the boolean array. Then we are having 8. 8, is it larger than 10? So this is 8, the third element. Is it larger than 10? No, this statement is false. So we put false here. Then we are having 12. Is it larger than 10? So this is the next element. So 12, is it larger than 10? Yes, it's true. Therefore, true is assigned there. Then we are having 20. Is it larger than 10? Yes, this statement is also true. So we assign another true. Then 50. Is it larger than 10? Yes. So we assign true here. 7. Is it larger than 10? No, it's false. Therefore, false is assigned here. And finally, we are printing the Boolean array, the second Boolean array. So in this video, we learned how to convert a one-dimensional array to a Boolean array. Thank you for watching. Welcome back. In today's video, we would like to replace all even numbers in a one-dimensional array with their negative. So first of all, we are importing the NumPy library as np. Then we are creating our NumPy array. So here we are using the arrange function from the NumPy library to create an array between 1 and 9 because end is not included. So this is why I tell 9, 10 is not included. and we name it ARR. So let me change this to array1 everywhere in the code. So array1, 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 and finally array1. Okay, so the name of my array is array1. I use the arrange function from the NumPy library to create it. First of all, after creation, I print this created array1. So when we see this is my array, this is the message and this is the array 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we would like to replace all even numbers in this one-dimensional array with their negative, meaning that, for example, 8, is it a negative number? Yes. Is it an even number? Sorry. Yes. So I would like to replace it with its negative. So 8 minus 8. 9. Is it an even number? No. So 9 is normally being there. 7, is it an even number? No. So we're putting it like that. But 6, is it an even number? Yes. So we would like to put negative 6 there. But how can we do that? So first of all, we need to learn how to distinguish an even number from the odd number. So if a number is divided by 2 and the remainder of this division equals 0, it means that number is an even number. Otherwise, it is an odd number. Okay. So if a number is divided by 2 and the remainder of this division equals 0, it means that number was an even number. Otherwise, it was an odd number. This is the definition of even and odd numbers. So we would like to first find all the even numbers and then replace them with their negative. From the array 1, each element in this array that is divided by 2 and the remainder of this division using modulus operator equals 0, it means that element is an even number. Replace that number with it's multiplied by negative 1. So when we are having, for example, 2 multiplied equal negative 1, so it means that we are doing this 2 multiplied by negative 1, and the output is negative 2. Okay, so the output is negative 2. So when we are writing star equal, it means that we are having the multiplication of that number. So for example, if x star equals for example 5 and x is originally x equals to, for example, 2, and we are having this equation, so x star equals 5, it means that we are having x equals x multiplied by 5, meaning that x equals, so we were having x equals 2, so 2 multiplied by 5, therefore x equals 10. Okay, so here is the same thing. We are checking to see if that element of the array 1 is an even number. If so, if this is true, then multiply that number by negative 1 and assign it exactly where it was. So we are seeing, for example, 8. We check to see if it's a negative, if it's an even number. Yes, because it is divided by 2 and the remainder of the division equals 0. Now replace 8 by this number. Replace 8 by 8 multiplied negative 1, which will be negative 8. Okay, so if this number is an even number, replace that number with its negative. So 8 is an even number, replace it with its negative. 8 multiplied by negative 1, it will be -8. Okay, so this is how it works. After that, we are going to have the next element. So here we are having the first element, first of all. So 1 divided by 2, is it equal to the remainder of this division? Is it equal to 0? No. So we're not going to do anything. We're printing 1. So then the next element of the array 1 is number 2. 2 divided by 2, the remainder of this division equals 0. Yes. Therefore, replace it with its negative value. So 2 multiplied by -1, it will be -2 here. Then we are having number 3. So 3 multiplied by 3 divided by 2, the remainder of this division equals 0. No, this statement is not true. Therefore, 3 is being printed with no changes. So then we are having number 4. 4 divided by 2, the remainder of this division equals 0. Yes, therefore, multiply it with -1, so it will be -4 and assign -4. We are having it here. So the same thing goes with the number 6 and 8. We are having -6 and -8. And for number 5, 7, and 9, because they're not even numbers, we are having their original value in the negative array as well. So here we learned how to do this for even numbers. But if we want to replace all odd numbers in a one-dimensional array with their negative values, how can we do that? Simply we remove this equal sign and we assign this. So it means that if that element is divided by 2 and the remainder of that division is not equal to 0, meaning that that number is an odd number, then replace that number with its multiplication by -1. Okay, so when I run the code, now we see that the odd numbers are being replaced with their negative value, and the even numbers, they remain unchanged. Thank you for watching. Welcome back. In today's video, we would like to create a random 3x3 matrix and normalize it. So we are importing the NumPy library first of all as NP. Then we are going to create our matrix here that is called matrix also. And we are going to generate random numbers with 3 rows and 3 columns and assign it to matrix. And then we are printing our matrix here. So when we are printing the matrix here, we see that we are having a 3-row, 3-column matrix here that are having random numbers between 0 and 1, and they are randomly being generated. Okay, so this is first of all how to create a random 3x3 matrix. Then we are having the normalization of the same matrix. So we call the normalized matrix to be having this name, normalized underscore matrix. In order to normalize my matrix, we are going to have this formula. On top, we are having matrix minus the average of the matrix divided by the standard deviation of the matrix. Okay, so using the mean function is going to calculate the average over all the elements of the matrix. So when I write down mean matrix, meaning that go ahead and calculate the average among all the elements of my matrix called matrix and calculate that number and return it for me. So we call the mean function from the NumPy library. So the matrix, all the elements of the matrix is being reduced from the average and then divided by the standard deviation of the matrix to have the normalized element. For example, and then we are printing it here. So let me first of all print the message here. The normalized matrix. So we are having the normalized matrix here. So when I run, we see that this is the original matrix here, and this is the normalized matrix. But how can we calculate, for example, this first element of the normalized matrix? This first element is basically calculated like this. The first element of the normalized matrix equals, so it is going to be equal to this number minus average divided by the standard deviation. Okay, average of all elements, standard deviation, and the standard deviation of the matrix. So the output of this equals this number. Okay, so this is how we can get from this number to this number. Okay, then in order to calculate this number again, we need to have this number minus the average of all elements divided by the standard deviation of the matrix. It will lead to this number. Okay, so this is how we can also do the calculation manually if we are willing to. So in this video, we learned how to create a random 3x3 matrix and how to normalize it. And also we learned that if we want to do it manually, it's easy. So we can do it using this formula for all the elements of the original matrix. Thank you for watching. Welcome back. In today's video, we would like to calculate the sum of the diagonal elements of a 3x3 matrix. So first of all, we need to create a 3x3 matrix. So here I use the random library from the NumPy, random functions from the NumPy library to create a 3x3 matrix randomly between numbers 0 and 1. So when I print my matrix here, this is my matrix. Then I'm having it being printed. So when I run, first of all, we see that this is the matrix. Okay, this is the generated matrix. And we see it here in the output. So we are having three rows, and three columns here. So now we would like to calculate the sum of the diagonal elements of this 3x3 matrix. In order to do that, we can use the trace function from the NumPy library to make the calculation for us. So in order to do the calculation, we can either do it manually. So in order to do it manually, you need to add this number to this number to this number. So the output of these three will be this number. Okay. So, but we can use the trace function from the NumPy library for the matrix called matrix. And we assigned the output number to this variable, and we are printing this variable in the output, and it is going to calculate the sum for us. So when I run the code, one more time, we are generating a new matrix with new numbers randomly generated between 0 and 1. And now the sum of this number and this number and this number will become this number that we see here in the output. So trace function can be very helpful. Thank you for watching. Hello everyone, welcome back. In today's video, I would like to write a program to find the indices of non-zero elements from this array. So this is my array called ARR. It has 1, 2, 0, 0, 4, 4. So these are the elements of my array. I would like to find the indices of non-zero elements. So in this index of this number, and this number. And we know about indexing. So it is index 0, it is index 1, 2, 3, 4, and 5. So these are the indices of these elements. How can we find them using a function from NumPy library without doing it manually? In order to do that, we need to use the non-zero function from the NumPy library for the array called ARR. This is going to return us the indices that are non-zero. So you see, this is assigned to non-zero indices, and we're printing non-zero indices basically. and we are having the indices 0, 1, and 4. So index 0 is for element 1, index 1 is for the second element, which has the value 2, and index 4 is for this element, which has the value 4 as well. So we see that in this video we could use the non-zero function from the NumPy library to find the indices of non-zero elements. So for example, here if I put 10, so when I run the code one more time, we see that now we are having index 0, index 1, index 2, and then index 4. So index 2 is number 10, which is non-zero. Non-zero function can help us to do that. Thank you for watching.